Station 2, base station 2, sir. Yesterday, Dhruti's notepad should be there. No, that will be there only one of the places. It's not one of the pads. It may be there. I think sir didn't leave any bag. He just dropped all the things there and went. I called Dhruti once.
You want to give a brief? Come here. Come here.
Hello, hello. Good morning, judges. We are from Team Dhruva, Team ID 10013. We are from Government College of Engineering, Karad, college in Maharashtra. And this year we have participated in IRoC 2026 and make our drone along with a base station. Our previous history with IRoC is also that we have been, this is our third time participating in IRoC competition. First time was our seniors who prepared for IRoC 2024 where they got AI 10 by their rover. Next, previous year we were new to the theme of the drone. So we were unfortunately qualified till just first 2 rounds. Later on that we weren't able to qualify. This year, fortunately, we are here in the for final run, and now I will brief what we made for this IRoC 2026. So the theme was to make a swarm or and implement swarm tech. So what a swarm tech should do is to interaction of two independent robotic systems. So as the concept of swarm, here we are implementing our base station, which holds the importance of charging the drone autonomously without relying on any feedback directly connected from the drone. It have an IRoC marker. It when the drone lands on the base station, it approximates the position, X and Y position of the drone. The base station is, our base station is having a novelty that it is precise with 0.04 mm of precision, as we are using lead screw mechanism, which is also used in 3D printers. And talking about our drone is, our drone consists of a microprocessor which is RPi-5 and a PIXOC with Arduino pilot firmware. And and yes, our no, it's okay, sir. And yes, our drone chassis is S500 chassis that we have using of carbon fiber. Yeah. What's that?
Team ID.
Yeah, our team ID is 10013.
So I think last 3 days your team is here, and the last 2 days you
Yes.
are struggling to repair something.
Yes, sir. Yes, sir.
So you could repair to the full extent, or
Actually, sir, it's now what happened till on 20th July till 6 p.m. everything was perfect, like everything from base station to drone, everything was hardware, software, everything was perfect. But on like after an hour, like on 7 p.m. of 20th July, we had a crash, and after that all our components, like major components, got burned out, like our RPi and our PIXOC, which replaced both in these 2-3 days, and completely changed the ESCs and motors that help us like recalibrating the.
very good.
Drone.
You could do it very fast.
Yeah. Okay. Thank you, sir.
And good that you got a slot today. Okay. So how is the confidence?
What, sir?
How is your confidence now after replacing all the?
Yeah, sir. It's much better than what we were having 2 days ago.
2 days ago.
Yes, sir.
Why you named your team as Dhruva?
Actually, this is legacy coming from our seniors. This drone, our IRoC competition participation is sponsored by our a technical club in our college, which is Space Club, and a space club. We are coming from a space club, and the Dhruva is a star which is most bright in this galaxy, in our Milky Way. So our team name is always Dhruva. It's a
Dhruva.
legacy of our team.
The club name is also Dhruva, space club name?
No, our space club name is Space Club, just.
Space club.
Yeah, yeah.
That is within the college.
Yeah, it's within a college.
And they sponsor.
What, sir?
They sponsor these programs.
Yeah, yeah. Sponsor.
Okay. Anything? Okay. Go ahead. All the best.
Thank you, sir. Thank you. 1943 होता है. लाइट्स वगैरे इथे हे केलंस ढकलू का जरा आतपर्यंत हे ठेवून दे जरा साईड.
B1, no? This one, that was B1 and this is B2, no? B2, okay.
काय सांगायला असतं फुल पाथ द्या मला काय करायचं आहे. हे लॅपटॉप ना माझा 50पेक्षा थोडंसं कमी आहे पण 50 असू दे टाकावं लागेल. पुढे जायला पाहिजे 3 mm हे थोडंसं अजून यायला पाहिजे. मी नाही करू शकत पण मला नाही माहिती. Sir, actually we are having some Wi-Fi connectivity issues. We are just figuring out and connecting to the RPICE Wi-Fi.
How much more time you need to start?
5 minutes, sir. Just 5 minutes.
Okay.
Yes,
So you have to start. We are losing time.
yes, sir. Sorry, sir, but we are doing.
No, if you exceed 5 minutes, we will ask you to vacate and give the slot to somebody else. Because we have to complete the task in the given time. Okay.
Yes, sir.
We also have some restrictions.
5 मिनिटं द्या. इकडे face. हे काय असं? हे काय असं? ते पुढे गेलं नाही. लॉक होईल. ऑफसेट चेंज केला आहे. आता केला दीदीला. ते सेव्ह केलं का? No, base station it's ready. No, that one laptop is like both all connection is on mobile hotspot.
Okay. So you want to restart the laptop or something if it's not happening?
I think it will okay. Connected. Yeah, it's connected. Just verifying that it's all the all scripts are in the place where it should be.
How many cameras here?
We are just using one webcam. We were earlier using the 1D LiDAR TF Mini, but just as I said that day before yesterday we had a crash, so that LiDAR got burned. We borrowed this from IIT Kanpur team, but unfortunately its refresh rates and our exhaust rate is not. Yeah, it's not.
But you could configure it.
Yeah, we could configure, but it would also take the time, so, and we had that time constraint today. So, प्रतीक दा प्रतीक दा एक एकच मिनिट आहे एका मिनिटानंतर ते सर लावून देतील दुसरी वेळा आपला नाही होणार मग ठीक आहे ते ड्रोन दे ठेव
It's ready? You can announce. You can announce that.
facing
Lightings are okay.
yeah
You
yeah
don't want anything off.
yeah it's okay it's fine आर्डिनोची केबल लावली आर्डिनोची केबल लावली तिकडे घे रिसेट करतात किती झालं झालं काही नाही ते मी रन करून बघेन Sir, is the display visible? Is my screen visible to you?
Yeah, visible.
Okay. Okay.
Go ahead.
You are ready?
Yes, sir.
Sairam, seats are loaded?
No, not yet, sir. Yeah.
what is the number we have noted down? 236. So the seed images are 236.
Okay.
236.
6. Okay. Now that heading is towards the north.
North.
So can they define the x and y axis coordinate system?
Yeah, so X is front positive and
Towards
this is north. Okay, towards north it's positive and toward this is east. Sorry. Yeah, towards west it is like Y is positive.
no, that's north towards north is x axis. Towards north is this direction.
Yeah, plus X is toward north and plus Y is toward west.
Okay, right.
Just tell us when you are ready to press the button.
Do you have RC? Fantastic. Okay, someone can narrate when after start command. You only will do it.
So our odometry node has started, and this is the terminal where we will see the logs of the flight. So I'll press the yeah.
Your head angle, how did you set? Which direction is forward in?
What's the battery voltage?
It's in north.
North is this side, right? This is north side, right? This is your heading angle we are asking. Where is your heading direction?
Okay, it's that side. Yeah, I'm sure. Yeah. Initially, battery is charged around 14.8 volts.
What's the emergency cutoff limit?
No, it's not displayed here. No, actually, we just tested it a few minutes ago. Yeah.
Cut-off voltage, sir is asking. Sir is asking cut-off voltage.
No, we have kept a timer of 5 minutes. The drone won't fly more than 5 minutes. So
14.8 seems rather less, right? Is it fully charged?
yeah, the battery needs to be fully charged for that.
No, on full charge, 3.7 into 3. That's more than. How many cells do you have? 4 cells, right?
Yeah, it's 4S.
So 3.7 into 4 would be much higher, no?
3.7. Yeah, like 14.7 is nominal voltage, but we are keeping it 14.8 to be like it will have a better flight time with this, and it
Okay.
is safe.
Your call.
Yeah. Okay, so our odometry is initialized, and we are ready to start our autonomous mission. And I'll just press F, and it will arm, and oh, okay, wait, I'll just. Okay, so everything is ready now. I'll press F button, and the drone will arm. Yeah. So initially, drone will reach the height of 2.5 meter, and it will start going in the front direction first of all.
Is there anything we can see here?
Yeah. Yeah, we can here see the position of the drone with respect to the base station. We'll see here some matrices, and okay, so yeah, so those matrices are showing the position of the drone, and the position of the drone is like we are plotting some blocks on the arena, and the drone is trying to visit every block such that it will take image of every feature available. Okay, so it was not able to. Yeah. What?
Was that an autonomous landing or was it a manual landing?
What?
Was it autonomously?
Yeah, it was autonomous landing.
Because of some constraint, is it?
Okay. Sorry.
You have understood.
Did it land because of a constraint in power?
Yeah, because our border detection node detects the border. If it will detect wrong colors, it could just block itself, like through the borders. Yeah, so the maybe image processing node is not working correctly. That's why it's happening.
Is charging happening?
Yeah, so the Docker has connected to the drone and the charger has been initialized. Yeah, and at the landing time, the voltage was 14.4, and after like some 5 minutes, it will rise up to. Yeah, okay. Okay, this timer is set to 15 minutes. The base station.
Are
Okay,
you
so-
able to pinpoint the issue? What is the issue in this? Why it came back?
Yeah, it's the glitch in the border detection node because it did not detected the borders correctly. It like detected so earlier because image processing did not work correctly. It detected some random colors as the border.
So it's safely returned to the base.
Yeah.
What
So
analysis?
because the drone thought that it has covered the whole arena, and that's why it's returned to the base station.
So you can fix it now?
Yeah, I'll have to change some. Yeah, I have to change the HSV ranges of the color so that it will detect those yellow borders. But for that, I'll have to like those images of the borders so that I can find out what are the HSV ranges of the border.
Do you monitor the battery voltage autonomously or? How do you do
Yeah,
it?
initially it was 14.8. After the flight, it came to 14.4, and after 5 minutes, it will charge up to 15 volts. We have kept a timer of 5 minutes. After 5 minutes, we'll see what will be charging.
So you can monitor the voltage after 5 minutes?
Yeah. Actually, we can monitor the voltage only through the base station. Base station has its charger and a display.
No. Can you monitor the battery voltage or not?
On the yeah, we can monitor.
You can. What is the voltage right now?
It's 14.4.
14.4. Already 5 minutes are over, after landing.
Uh,
Wait. Don't touch anything. Wait.
Yeah, he's just seeing the voltage. What's the voltage?
No. You don't have on the monitor, is it?
Yeah, we don't have it on the monitor.
Okay, then you can see here and tell.
Yeah. Okay, it came to 14.9.
No, not can be. What is the number? Right now, what it is displaying?
Yeah, it is 14.9 now. It was previously 14.4. So the battery has charged slightly.
So it is 14.9 now.
Yeah.
To be precise, 14.94.
Okay,
Yeah.
now how much time you need to make some changes in the software and try once again?
Approx 10 minutes.
So it is 9059, right now 905.
Okay.
So 9:15, you have to press the button again.
Yeah, sure.
Otherwise, you have to probably vacate the place.
Okay, sure.
Okay, go ahead. Don't talk to anybody. Be on the job.
Yeah. I would also like to
Don't talk to anybody. Be on the job.
Yeah, sure.
5 minutes. Sir, sir.
So the timer
Our
has completed,
timer has
and
completed,
the
and our
base station charger has
like completed its
yeah.
charging and going to its home position.
Okay.
Sir, there is one request. If we can take the images of the border so that we can find out the HSV ranges.
Not allowed.
Okay, sir.
Is a CCC charging algorithm that is much required for a long durability of a battery, and that a battery is like a 4 cell, no? So and it have 5 connectors. So how we usually charge is we do balance charging, and that increases the life of the battery. Okay. So what we did was we like find out the internals of the battery, how it works, and we made that genderless locking mechanism of, on the both side of the on the base station also and on the drone also.
Oh, this is wireless charging.
No, no, it's like you see that 5 plates. It's a plates cut from Coca-Cola or like cans. We like remove the first layer of that to make a metal contact, and inside that from it's 3D printer both Dockers. So from inside we have alternatively placed the magnets, neodymium magnets. So what it does is it's placed in such manner when that base station Docker comes near that our drone Docker, it aligns itself according to the and also the base station Docker is having some flexibility in like if your the drone changes in plus minus 30 degree, so it's able to connect.
Why did you put these images on the?
Actually, those images was we were like when we were trying to fly, the IRoC detection was not happening. So we thought that it's maybe all the white area is having. So we thought the texture would help having some features to take it a vertical clip off.
So the charging port is there on the bottom side or side?
On the black one.
No, that is okay. On the drone, where is it?
I can't understand. Like, can you please?
Charging
Charge the
port.
battery.
Yeah.
Where it is on the drone? Which side? That is.
On that side. On that side.
That side.
It's.
See.
So the from base station, the charging port is coming and docking or to which side? That side.
Yeah, yeah. From base station, it's come here. Like first, like I will explain in the total flow. When drone lands, our autonomous script runs. There's that webcam which detects the ROC position, XY position. Send it to the Arduino Uno. Arduino Uno is controlling 3 motor drivers and one battery charger. And that battery charger, like when we see XY position, we have calibrated it such that it comes to the in X and then in Y, and just pushes some centimeter a bit to drone, like to confirm a better charging contact.
Okay, we'll see anyway after this. We'll see else.
Yeah, right. Sir, just
this you highlight that how we are charging.
Yeah, balance charging.
No? Not balance charging. Balance charging is okay. Okay. Whatever you have done for that extra feature you have added, like you have put magnet to LSL to line, all these things, all your points you should highlight.
Yeah, yeah, sure, sir.
When you briefed, did you tell about all these things initially?
No, no.
That whatever you are doing indigenously by yourself, that is okay.
Because that is innovation.
It is having weightage.
Innovation part.
Okay, anyway, I don't know the distance whatever is doing.
So, sir, just a doubt. That charging is like is done. So I just wanted to ask, can I just click one button on that?
That you can do now. Till you fly anything you can do, not a problem.
I can do.
You cannot scan the arena.
Yeah, it's okay. Sir. Can I just press a button? Siddhartha. ते बॅटरीचं परत चार्जिंगसाठीचं बटन दाबायचं. ड्रोन बाहेर लागतोय का? विचारतात ते. बटन दाबून घे चार्जरवरचं आपल्या हे करण्यासाठी. ओके 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 बरोबर.
You are telling this one.
Yeah, this is
charger.
This.
So you will be aligning it here and here, and that is that is coming like this.
Can I explain briefly right now?
Meantime, yeah, you can go there and explain.
Okay.
So we have changed some HSV values. Now it is supposed to like detect the images, borders. I'll start in 1 minute. So after the drone lands and it takes off again, before that, to be safe, we like restart our odometry node, so it will not have any positional offset. Okay, so just a small request that can we restart our flight controller by touching that?
I did not get what you want to do exactly.
We just want to reboot our flight controller. We'll have to remove the wire and replug that on the, it's on the drone flight controller.
Do it.
Yeah, okay.
Shall we do one thing? I think
Yes,
it
sir.
appears to me you need some more time.
No, sir. It has been. It's just some glitch. It was just some glitch. Our process did not start, and it has started now. I'll just need exactly 1 minute.
Yeah, go ahead. I will not be on the dais. So Sairam, I think we'll go for the next team. Meanwhile, they can attend to that. At the end, if time permits, we'll give them the slot again.
Sure, sir. You guys remove the base station.
Take it out. Take it out. There is a time slot.
If the scale accuracy is more. Okay, 1.999. Yes. You can choose the setting you can choose. Station 1 is not. Not on it. Setting is not. No. Drawn on this. Okay. Your front. Which is your front? Okay. This should be oriented towards. You can take it. Second. After partial setup, one of the come here, reach the bridges, 3 minutes you have.
Sir, I want to tell a few words to this team. Actually, I think you are struggling since 2 days for the. So, this learning experience will be a bit harder, but I think it has given you a lot of lessons. That understanding about your drone, the various aspects of the drone software configurations. The point what you are learning will remain lifelong with you. See, this winning and losing is a part of the things. Which obviously you will be able to figure it out that somebody is going to lose, somebody is going to win when multiple teams are participating. But that learning is very important, and you should cherish that you got the opportunity, and this overall process for this will be with you. I wish you best of luck. Please cheer it up. Okay.
Okay. So, good morning panel. Myself Ashwin Hari and this is Deepan Kuran and we are team RIG from National Institute of Technology, Calicut. So, our system, I'll go into explaining how our system works, the whole flow. So, for navigation, we'll be using a fusion of optical flow and the IMU inside our flight controller. That will be fused together inside the flight controller itself and it will provide us the local position. So that will be used for the navigation as well as for getting the coordinates of seats. So, and then our navigation flight pattern is a lawnmower type pattern. So what it will do is after taking off, it will find the nearest corner and then it will do a sweep in that edge to get the, it is a blind spot since our camera is facing forward, tilted little bit forward. So to cover that blind spot, after finding the corner, looking towards the yellow line, it will do a sweep. Then after completing it, it will come back to the same corner and do a 180-degree yaw turn and then start a lawnmower motion. And after completing the lawnmower motion, it will again do a 180-degree turn to look towards the base station and then start an RTL along with IRoC detection. So RTL will get it closer to the base station and once the IRoC marker that we have used in the base station is in the view of the camera, it will automatically switch from RTL mode to a loiter mode based IRoC correction mode, which will correct the x-axis and y-axis and land it onto a base station. And once it's landed, automatically itself in our GUI, the seeding will automatically start. And then once the seed has been transferred, so our seeding is off-boarded. We'll record all frames while flying. And once landed, and in the flight itself, it will start sending the recorded frames. And so that while landed, all the recorded frames will be in our base station PC, the laptop. And in that, once landed, it will start the verification, seed extraction. And along with that, simultaneously, the docking will also start. And once docking started and charging is started, in the GUI itself, we can view the charging status. Now, to explain more about the seeding, I'll hand it over to Deepan Kuran.
Good morning, panel. Myself, Deepan Kuran, and as Ashwin told, we are doing a complete off-board seeding. So once the drone starts flying, we'll be continuously transferring the files to the base station so that after landing, we don't have much delay for the file transfer. So the confirmation starts only after landing. So basically, we have a 4-layer pipeline. The main aspect of this pipeline is CNN. So we'll be using CNN mainly for getting the features. So other 3 aspects are HSV, LBP, and Gable. Each of them have its own weights. So after passing through HSV, LBP, and Gable filters, then we'll be going to CNN. So for CNN itself, we have mainly 3 layers, which are linear, like actuations, linear layer normalization, and GLU. So after these 3 actuations, we will be converting a 786 sized vector embedding into a 256 size so that we can easily match it with the seed features. And we'll be using cosine similarity to just match the features, thus confirming the features with the seeds.
What is that symbol you are wearing on your T-shirt?
That's a club's mascot.
What?
RIG is a club in our college. We are focused on.
What it indicates? What are those things?
A robot.
Just a robot.
Robot?
Yeah, it's just a robot, symbol of a robot. So we are a robotics club in NITC.
Robotics club.
Robotics
this is your
club
symbol.
Huh?
This is your club symbol.
This is our club symbol.
Something you told IMU. IMU means what?
Initial measurement unit. So it consists of accelerometer and gyroscope. So it gets the orientation of the drone and the acceleration values, and our optical flow will get the velocity values. Now, those 3 paired with the height value that we are getting from the rangefinder, which is in the same module as optical flow. So by combining these 3 values, it can get the local position.
So
displacement, I guess.
IMU cannot give height, is it?
Huh?
IMU cannot give height.
IMU has an internal barometer, but rangefinder is more accurate.
More accurate.
Accurate, yes, sir.
So
what
which
is your,
network is used? Convolution network, which one it is?
We are using a pre-built network, convex tiny. So we'll be tuning the features of convex parameters of this network so that it will be apt for our pipeline.
Okay, so it is a custom built net is what you're telling.
It's a pre-trained model, and we'll be tuning the parameters.
Okay. So how many trainings you have done? Like how many images you have trained?
We didn't much train on the images. Based on each flight, we'll be just iterating through the flights. So if you are going through that, approximately 10 tests have been done with the current model with which we are using.
your object detection, that it is your real time you are doing, or
No, sir. While flight, we'll be only transferring the files.
Okay.
And once the docking is done, then only we'll be starting the confirmation.
what is your trajectory path?
It's a lawnmower path. Lawnmower as in, first it will give a roll until yellow is detected on one side. Then it will give a pitch, again a roll on the opposite side, like that a lawnmower motion.
Okay, you are having that full coverage.
Yeah, full coverage, yes.
Okay, right.
Okay, go ahead.
All the best.
Thank you, sir.
Sairam, have you loaded the seats? Okay, 367. Okay. Okay. Now heading direction is towards north. Can you give the what is definition of that XY coordinates?
Will be positive, y will be east.
Positive y is east. Okay,
And
towards east.
Yeah, towards east. And positive x is towards south.
Towards south.
Yes.
Okay.
Hello, panel. We have uploaded the seed images. Now, yeah, anytime we can start the mission. Sir, can we start?
Can you report the battery voltage?
We have to start the mission, then only all data will start coming.
So how are you sure that the battery is charged even now?
Yeah, it is charged full. We checked multiple times. 16.5. It is charged to 16.5 volts. The exact reading we can get once we connect it. Start the mission.
Okay.
So you are ready to go?
Yes, sir.
Feeling confident?
Yes, sir.
Go.
Thank you.
All the best.
Okay. Okay, sir. So we have clicked the start mission. Okay, once clicked it, since it has to do a lot of pre-initialization checks, it will take some time. So you can view in the GUI tab all the logs that it is showing.
Do you have to press again?
No, we don't have to press again. It will just take some time.
It will take some time to
initialize. Yes. Okay, battery voltage is shown right now, 16.2 volt. Sorry, this was just an initialization. Now it will start. Next will be the correct start. Sir, there is some. We have to change a path to the file. It will only take 2 minutes. Can we do that and start again? Same attempt.
No, wait. You need to do something on the PC?
Yes, in the GUI we have to do a...
You have to change something?
Yeah, change something.
Change it.
Thank you. Sir, can we start again?
So you are ready?
Yes, sir.
Don't be in a hurry. You have done everything required?
We have to start the mission to check if it...
Once it is flying, then it is for starting.
Okay, so we'll use this as a check, and then if it's okay, we'll tell you and we'll restart again.
So you are ready to start?
No, sir. Can we check for now? No, this one.
No,
Can
no.
we check if it will work? The change that we made.
Listen to me. Once I give a go-ahead signal, only one press of one button is allowed.
Okay, sir.
So if you are ready for that, you tell me.
No, sir. We are. We'll check again. Okay, sir, we are ready. We checked it and it's working. We can start.
Go.
We have clicked the single button. The voltage right now is 16.17. 16.17. Okay, sir, the mission will be starting now. The drone has armed. It's about to take off. Okay, sir, the takeoff has been completed. It is set to take off to 2 meters height. Now it will start the corner detection. It is starting the initial sweep after detecting the corner. Now it's coming back to the initial corner. Corner has been detected. It will hover there for 5 seconds. Okay, the 180-degree change has, yaw has started. The lawnmower motion has started. So now the loop is complete. So it will turn 180 degree to return back to base station. Yes, sir. Now it has started the RTL motion until IRoC marker is detected. IRoC has been detected. Now it will hover there for 5 seconds, then switch to IRoC alignment. It's starting to do the alignment. So I am requesting to take it and place it inside so that the detection, automatic docking will start. Can I place it inside? Manual intervention.
Here, one of the blade came out during the fly?
After landing, due to the sudden stopping, it came out. It didn't land properly, right?
After landing it came out or before
No,
landing?
after landing, when the motor stopped, it came out due to the inertia. Can I intervene and stop? Can I, sir? Can I?
Yeah.
Can you explain what happened?
Okay, the docking, it works like after docking, when this extrusion comes forward, the extrusion is supposed to stop when the battery connectors are connected. The pogo pins, it is magnetically connected. So when those are connected, it is supposed to stop. And due to some misalignment, it is misaligned and it is not connected properly. That's why it never stopped.
Okay, stopper misalignment was there. That's why that you could not stop that.
It
Is
didn't
like
stop. And battery charging also didn't start.
Okay. Okay. So manually you want to intervene now.
Can I just touch and if I give a little nudge, it will start
What
charging.
you want to align?
Yes, yes.
Align.
Yeah, battery charging has started.
Now what is the initial voltage now?
Wait, sir. 15.09.
That's the charging voltage, I suppose, because the battery had dipped
15.15. 15.15 is the starting voltage.
This is the voltage that the charger is imparting, because this is the voltage that the charger is giving. The battery
No. It's the current voltage of the battery.
Can you check the voltage when at the time of landing it was 13.5 or something?
Okay, that I can explain. During the flight.
No, not. It's
yeah, during the flight, what was the voltage displayed?
The displayed voltage will go way below because during the flight we are taking raw voltage readings from the PIXOC, and due to that it shows way below. Like the actual battery voltage will be above 14.8 only, but the one shown by the PIXOC, we are getting the raw value from the PIXOC. We are not doing any filtration on it. So the raw value will go very less. But the battery voltage will be safely above. Right. We can change the tab and show the battery charging tab. There we can see the start voltage, current voltage, and the time elapsed.
Is data transfer happening?
Data transfer is over and the validation is also over. That's what's being shown on the screen right now. There are 3 features that were detected. Yeah, there was
Can you
one
read out
false detection
the
as well.
coordinates? It is not very clearly visible.
Okay.
Match.
For the feature 3, feature 3, x is -1 and y is -1.468.
Minus 1 point?
468.
Okay.
What is x-axis, that feature 3?
Minus 1.006.
Minus 1.066.
006.
006.
Is
Okay,
is it
can you show
captured?
that third whatever the image, high resolution image?
This one.
Show it again. You mentioned.
Yeah, this one. Yeah.
It's captured partially, is it?
Yeah.
So we have only detected feature 3 has been both feature only a partial detection has been partial in the frame.
Can you
only
zoom that?
partially detected.
Can you zoom that portion?
In the GUI we can't zoom. We have to go to the folder itself to zoom.
Sir,
we got 2 features. So we got feature 3 and feature 1. But in the camera frame only a part of it is detected.
No.
See, feature offset, can you tell?
Okay, feature 3 we just told. Feature 1 I will tell.
So when you are telling feature 1, 2, 3, or less like the one we have given S3, S6, S7, Sai, can you confirm?
No, Sai. Sairam.
You can open
Sairam.
both the seed images and seed
we'll
images
compare
versus the result images. You can compare and show on the screen, side by side.
We will compare and we'll tell shortly.
This is one of the image. Other seed image is what? Zoom it. Yeah, next. So these are the 3 seed images what we have provided.
So corresponding to each seed image, they can show their acquired image and the coordinates with respect to the base station.
So the image on the right is the seed image, and on the left, this image has been detected as the.
No, wait. That doesn't correspond to the image on the right.
Yeah, it was a false detection.
Yes, sir. This was a false detection. It didn't.
False detection.
Yeah, it detected another feature as this.
So as far as that seed is concerned, it is a false detection.
False detection, yes, sir.
Then go to the next seed.
It is again the same feature itself which detected as the
No.
another
Go to
feature.
the next seed. Corresponding to that you are showing.
This is feature 1 and this is what we got.
How do you know this is what you got?
Can I open the folder and zoom the image that we captured?
No, from this, how do you know? From this, how do you know that that is the feature?
Okay, this is what we detected, and
so you are not sure whether what you detected corresponds to that seed or not, right?
what's I didn't hear you.
Are you sure whatever you have identified is that seed?
No, no, sir.
You are not.
No, not sure.
Okay. At least you have the coordinates of that?
Yes, sir.
You tell those coordinates.
X is minus 2.16.
Okay.
Now y is plus 3.710.
Okay. Go to the third seed.
The third seed was again a false detection.
False detection.
Yes, sir.
So, 2 seeds are false detection.
Yes, sir.
One seed you are not sure unless you go to the folder.
Yes, sir.
Then go to the folder.
No, sir. This is also a false detection.
Okay. So, we will note down 2 false detections.
Yes, sir.
And one you are not sure, but you know the coordinates.
Yes, sir.
Correct?
Yes.
Okay. So, shall
Sir,
we
is it
come to the
possible
end?
to go for another try?
You want to go for another try?
Try, yes, sir.
Go.
Okay, thank you, sir.
Saira, you have to change the heading and seats. Dhruti, the person write to you. His mobile you check.
Sure. Shairam, that seats are 145.
Yes, sir. I confirm.
That,
Seats are 145.
Heading is?
West.
West. That can you ask?
So they want to go for battery change.
Okay.
Go ahead.
Why your old battery did not charge, is it?
For one more full mission. It won't have enough for one more full mission.
No, what I'm asking, your old battery was charging, it did not charge.
The charging is slow right now.
Slow.
We've kept it so for safety.
Okay. You have to do it fast. You are running out of time. Otherwise, you have to abort in between.
So, can we
wedding,
start now? We are ready.
Before starting, wedding direction is west, towards the west.
Okay, XY, can I tell now? It
Yes,
changes.
Can you?
Yes. So, Y will be north, plus Y will be north.
Plus Y north, okay.
And plus X will be east.
Okay, towards the east is the plus X. Okay, right, you can go ahead now.
Okay, sir.
All the best.
Thank you, sir. We have given the command.
You start.
Yes, sir, we have
and
given the start
immediately you tell the battery voltage.
$16.35. Initial voltage 16.35. The initialization check has been done. Now it will move on to running the main mission. Okay, sir. The drone has started. Now it will proceed to take off. It is correcting the yaw to face the yellow border. Now it will start the corner sweep. Hello, sir. I think there is some glitch. The voltage value is currently not showing on the GUI. After landing, we will show it on the final voltage. It has completed the first sweep. Now it will start the lawnmower motion.
So this is just a battery voltage display only. The remaining other things are okay.
Yes, sir. Remaining everything is okay. Okay, just the battery voltage window.
See, don't worry about the explanation right now. We can, but I'm just probing that you are not having any other missing parts.
No, sir. Everything else is okay. loop has been, the lawnmower motion has been completed. Now it's turning 180 degree to start the RTL motion. The RTL motion has been started until IRoC-U is detected in the camera frame. IRoC-U has been detected and now it's hovering. Now it will start the IRoC-U alignment. Y alignment has already been done since it's aligned in the Y direction. Now it will start the X alignment. Okay, so it has landed inside the base station. Now the docking, after the seed images are transferred, docking will start. Yes, sir, the docking has started since the transfer of seeding is completed.
So in this docking process, it's just a blind mode of pushing. How are you identifying that docking is complete?
There are limit switches placed. Okay, it has connected and charging has started.
So with corner switches, it is identifying, right? Which corner switches you are referring?
Sir, what? Okay, there are limit switches on both. When that is coming from, when the first extrusion is coming, there is a limit switch placed at the end of there.
On the railing, on the railing.
On the railing itself, the limit switch is placed so that it will, when it reaches a limit, it will stop. That is the maximum limit it can go. So to align the drone.
But how it will identify that it has touched the drone? Like any sensing is there?
No. The touching of drone just blindly goes, assuming that drone is there.
Okay.
And whether drone is there or not, it will stop. To explain further, I'll give it to.
Okay, it's okay. I can understand because you are having a mechanical stop.
Can you check that what is the initial voltage?
Okay, sir.
You can see here and tell.
Initial voltage. Visible, right? Okay. It's not. Okay, sir. So this is our charging tab. Here the start voltage was 15.36.
Okay.
When the battery voltage started, and this is the current voltage.
Okay. 1 volt it is increased.
0.1 it has increased.
0.1.
Yes. About the charging, I have to say that it's a bit slow charging. For the safety, we have given the charging current as 2 amperes only, so it will take some time. Meanwhile, we can check the seed images. What? Oh, okay, sir. Can we move on to the seed?
Yeah, you go ahead with the image.
So feature B has been detected here.
No, first you display the seeds.
Yes, sir.
Corresponding images you show.
Yes, sir. So this is the on right side we have the seed that was given to us, the reference image, and on the left side this is the seed that our system detected.
Can you explain whether it is matching or not matching?
It's not. Yeah, it's not matching, but both are rocks only, but it didn't match the exact. Wait.
I think your just can you see other image what you have taken, whether it is matching with the second one?
No, so it detected the same image.
Same image is taken both time?
Both time it detected the same image. Like for 2 seats, it detected the same image. Yeah, the second detection is a wrong detection, false detection. The first one, our system identified both as rocks. That's why this happened. Like,
How about the third one?
the third one is also a false detection. So, yeah, 2 false detection. The first one, I would like to say that since both are similar rocks of similar color, it detected like that.
Okay.
Top view image.
Let me ask you a question.
Yes, sir.
Your first sortie is better or second sortie is better in your view? What is your team's view?
Second sortie only.
Second sortie is better.
Yes, sir.
Why so?
Without manual intervention, it landed properly and docked and
From the point of view of landing and charging, it is better.
Yes, sir.
But from the point of acquisition of images and matching and finding the coordinates, which sortie is better?
The second, in the first one, we had one detection we were unsure of, and the 2 detections were false.
Ah.
In this one, 2 detections are false only. The third detection, it is false, but it is a similar from the top view.
It doesn't matter.
Yeah.
In the first,
but we feel like the second one was better.
No, in the first, 2 detections are false. One is identified and you could find the coordinates. In the second one, all 3 are almost false. Is it like that?
2 are false completely.
Third one?
Third one, yeah, it doesn't match the image. Yeah, when
It
we
doesn't
see
match.
it doesn't
So
match.
it is a
Our
false
system,
one.
yeah, it is.
Clearing
Okay,
them.
from that point of view, first one is better.
Arena is cleared for them.
From seeding, yes.
From seeding point of view, first one is better.
But
from landing and charging point of view, second one is better.
Second one is better.
Good. Well done.
Okay,
Thank
sir.
you.
Thank you, sir. Sir, what should we do now? Is there anything? We can wait, or we should wait for charging or leave?
Currently, what is the charging?
Can I go inside and check? The UI is... No. Yeah, I'll go in and check. The UI is not responding currently. It came. Okay.
What is the increase in the voltage? Delta, you tell.
I'll go and check.
Can you attribute why it is not able to identify the object seed images?
Can I tell the voltage? Voltage is 15.65.
No, not the voltage. What I want to know, can you attribute the reason why you are not able to?
Prashant, 1 minute. He was asked the present voltage value. That's why he is telling that.
Yes. Should I tell again?
Now, how much is the increase because of the charging?
Now it's 15.69.
When you started, what is the voltage?
Started was 15.36.
So 0.3 increase is there.
0.3 increase is there.
So wait for some time.
Yes, sir.
When it reaches delta of 0.5 volts,
yes, sir.
You tell us.
Yes, sir.
Meanwhile, you can answer him, whatever he has asked.
Sir, for the seeding, could you show the features? Yes.
No, I don't need a generic. I want a just course understanding. What is the reason? Can you guess and tell?
Sir, can I come there? For the seeding, the features which we trained on were different in all, either texture or shape. But here, both the features, like more than one of the features, have similar texture and shape. So it was based on the texture, like the corners and edges. So it is detecting more or less the same corners and edges. So that's why we are getting false detections for based on this feature.
What could have been done?
If I have to improve, we can improve on the HSV. I gave a weight for HSV. We can improve the weight of HSV because here we can see that all of the features have different colors from the background.
See this, you could have taken the edge detection. Edge detection could have matched easily, no?
Yes, sir. Like I wanted a bit more accurate readings. So edge was a bit crude reading.
No, both you can combine edge detection as well as that your cosine matching and all.
Yes, sir. We'll try to do that in the future.
Okay, okay. All the best.
Thank you, sir.
The correlation factor you should have arrived, and then you should not have stopped the comparison till even though you have got a match. What you should do is you should compare the entire scene, generate correlation factors for each of the matches, and then whichever has the highest correlation, you just have to take that.
Yes, sir. Thank you, sir.
Yeah.
Just saying, right? Sir, we had missed a point while briefing about the thing, about our project. We have a unique way of charging mechanism. Can we explain that? It won't take time. Can you give us 1 minute to explain about our charging and docking mechanism? The novelty in our charging and docking mechanism.
Can you repeat?
The novelty in our charging and docking mechanism. Can you give us 1 minute to explain that?
Yeah, you can come here and explain.
Hello judges, I'm Sendil Nathan. I was working on fabricating this docking station. We have made our docking station using aluminum extrusions. As you can see, we are using a sweeping mechanism to corner our drone. The first rod sweeps the entire arena and pushes the drone to one end. And the second rod pushes the drone to a corner. Why we preferred cornering mechanism instead of centering mechanism is, once we corner the drone, the entire arena is almost empty now. So once the charging of the drones has started, we can, if we are expanding to a SWAM technology or something, we can also include one more docking station in the existing arena. So it is expandable to 2 dockings, dual dockings. And for the docking, we have been using this spring-loaded thing. This is attached to our drone. And here you could see 6 slots in a hexagonal shape where we are attaching magnetic pogo pins. To give a better idea about pogo pins, if you are familiar with smart watches, where you will, when you're connecting your charger, the magnets get attached to it. If you, to ensure the polarity is correctly matched. So we are using the same technology, same thing here. So this radial spring is attached to our drone. And there will be one more thing. This thing will be attached to our base station. So this will be attached on the a black color smaller extrusion. So when it comes and sweeps and touches the drone, the magnets get attached and the docking happens. And we have the spring here, so it could account for any planar misalignment. And the springs can expand and contract, and it can ensure there is a smooth docking. Yeah, that is it.
And my name is Aditya AS from RIG. So I am here to explain about the charging mechanism. The main thing is about not novelty, it's about the safety. I have considered the balance pins also. Since lipo charging is something that is very sensitive, and that battery is so sensitive actually. It can be exploded at any time if it doesn't charge it safely. So for the safety, we considered the balance pins. That's why we have 6 pogo pins there. It's a 6 set of pogo pins, where the 3 set we will be using for the charging, because the pogo pins are rated for 1 ampere only. We need more than that, right, for charging. So we set that accordingly. So 3 set for ground and VCC of the charger, and other remaining for the balance pins, 5 balance pins for the forest battery. And other than that, we use the IMAX B6XC charger. That is a normal lipo charger, and instead of that, needs a manual intervention. So to avoid that, I used a microcontroller with an optocoupler to trigger the start button for that. That's it. Thank you.
Good. Good job. You are ready to brief?
So the voltage is now 15.8.
Okay. So you can move away.
Okay, sir. Thank you. Thank you, sir.
A very good morning and Jai Hind to
Good
all
morning.
the jury members. We are Team Luma, and we are from the LNM Institute of Information Technology, and we are currently presenting our Ascend. Our Ascend has all the capabilities that were mentioned in the rulebook, and it can perform all the tasks autonomously. Our tech stack comprises of a single camera, with the help of which we are able to complete the entire mission. What we are using is, we'll travel the entire arena using a lawnmower pattern and try to detect all the images that were given. Also, what we'll be doing is, we'll be making an entire 3D map of the arena using the camera itself. We'll be having the image detection, also the 3D map of the entire arena, which will show the textures as well as the terrain of the entire arena. Yeah, thank you, sir.
How do you do 3D mapping?
Okay, so what we are doing is, we'll be traveling the entire arena using a lawnmower pattern, and while performing the lawnmower pattern, what we are ensuring is, we are trying to overlap a certain amount of strip we have covered. For example, if we have covered a straight strip along this boundary, and the next time we are going back after taking a right turn, for this particular case, we'll try to overlap the images that were taken in the previous run. This overlapping helps us making more pixel matching and helps us combine both the images. What we are doing is, we are building a mosaic which will stitch all the images we have clicked during the entire traversal. While stitching all the images, what we'll have the output will be the map of the entire arena in a single frame.
Center, there is one feature, you know?
Yes, sir.
Arena center.
Yes, sir.
What is the approximate height of that?
I guess 60 to 70, yeah, 60 centimeter.
60 centimeters.
Yes, sir.
How accurately you can measure using your 3D mapping? No, don't worry, we are not asking you to do it. Yes. We are not asking you to do it.
So around 5 centimeter approx, around 5 centimeter approx accuracy.
5
So
centimeter.
plus minus 5 centimeters, say, if it's 60, then 55 to 65-ish.
See, is it that depth camera you have on the onboard?
Yes, sir. We have a depth camera, but the depth camera problem is that it's too complicated to match the RGB photos with the depth images, as if we are not using any proprietary libraries, it's like really heavy. We are using an RTEV or RTEV VIO.
Don't worry, whatever system you are using.
No, sir, we are using RTEV VIO. It also works the same, but it's like very heavy.
Whatever system you have, how accurately you can calculate the depth of that? with the system what you have?
Plus minus 5 centimeter. If it is of about 60 centimeters,
5
what can be
centimeter.
calculated?
Yes, sir.
55 to 65 centimeters.
50. So plus minus 5 centimeters.
plus minus.
Very good. Any questions?
Also, so what we have tried to do is not implement many heavy soft.
No. I'm not asking you to do it. I'm trying to understand what is the capacity. Okay.
For navigation, what are the sensors used?
So for navigation, only the camera is being used.
That
And
is-
optical flow is like, we have also an optical flow, it's redundancy. If something happens to the camera, it switches to the optical flow.
Optical flow
Yes.
sensor. So same camera for both feature detection
Yes,
and navigation.
In case we lose the camera feed, or if camera is unable to detect the features of the ground, it loses its quality, it automatically switches to optical flow sensor, and it will stabilize itself at that very position and not drift or crash into anything else.
You are from which town? You are from which town?
We are from Jaipur.
Jaipur.
Yes.
You came yesterday or day before yesterday?
Day before yesterday.
Day before yesterday. Comfortable?
Yes, sir.
Had breakfast?
Yes, yes.
Go with confidence?
Sorry?
Go with confidence? All the best.
Thank you, sir.
Go ahead.
This is our GUI, and here we'll be running all the commands. It will be a single line command, as said. We'll be starting the mission with a single line command. As soon as we press the enter, the mission will start. Everything will happen autonomously, and also this is the entire GUI. Here we'll have the images as shown. This will be the 3D map. And as we scroll down, we'll see all the feature detection as well, corresponding to the LR image which has been seeded to us. Yeah. Thank you, sir.
Hello.
heading is in that direction only, right? Yes. Sir, the heading direction is north and the seed images are 137. The heading directions are, the seed images are 137.
Sir, we are ready. Can we start? At your command.
Can identify your X and Y directions.
With respect to north, the x-axis is aligning with the north, and the right side, what? East will be the y-axis. North is the x and east is the y.
North is X and East is Y.
Yes, sir.
Right?
Yes, sir.
So you are ready to go?
Yes, sir.
Confident?
Yes, sir.
All the best. Go.
Thank you, sir.
What's the starting battery voltage?
Yes, sir. Just a second. The starting voltage is 16.14 volts. So we have started. The drone has been armed. The drone has climbed to an altitude of 2.5 meters and it is currently trying to align itself with the base station. Right now the drone is detecting the yellow line and it is approaching one of the corners so that it could start its survey.
You can take over manual control if you want to, if you feel like. You'll lose marks, but you can do it.
Can you announce what's happening?
Hello. So what happened was the yellow line was not detected. Also, the land command was sent, so the base station started moving on its own. We are fixing that.
You want this light off?
Yes, sir.
These light to be off because it's reflecting.
You can tell there.
This side light only.
This side light. The side lights. The side lights. उससे कुछ नहीं होगा, वो लाइटिंग की दिक्कत वो क्या हुआ ना, चक गया वो एकदम से, समझे? वो लाइटिंग की दिक्कत थी। या so then top वाली रहने दे ना, ये बंद कर so we can turn on the top one. Can we turn on the top one only? Okay.
लो तो नहीं पड़ेगी ना?
नहीं, लो लाइटिंग नहीं होगी, ऐसा डाउट
सही है ना?
हाँ, इतनी लाइटिंग में सब
Sufficient. Good to go. No.
वो ये सही है, लाइट ये जलवानी है। चला गया था।
So we are giving it another attempt. Yes,
Did you completely understand what has happened and
actually, so
accordingly
what happened
modify?
was everything was going according to the plan. What it was supposed to do was go back and detect the corner, but what it missed was it wasn't able to detect the yellow line.
So don't worry, you understood.
Yes, sir. Yes, sir.
And did the modification accordingly.
Yes, sir. We are trying.
So you are ready to go for second attempt.
Yes, sir.
Go.
Just a minute, sir.
You clear the folder.
Sir, can we do a small HSV calibration?
Yeah, you can do it.
Thank you, sir.
So what they ask, what you want? What does it mean? Are you going to move the drone? Not allowed. Without moving the drone, you can do whatever you want.
So we are not going to flying the drone. All I'm going to do is hold it in my hand.
You cannot.
Okay, sir.
From the base station, whatever you want, you can do it.
So the drone is arming again. The drone is trying to align itself with the base station, and it will fix its yaw as well. So we'll take a manual control over here. So we landed it manually because again it wasn't able to detect the yellow line. There is some issue with the contrast of the yellow for which we have trained our camera, and the yellow, the shade of yellow we are seeing over here.
So what is the plan of action now?
So we are trying to change the HSV values manually.
You need some software changes?
No, sir, just a change of few numbers in the code.
Some input parameters?
Sorry?
Some input parameters you want to change?
Yes, sir. Yes, sir.
So, and this will be your last attempt.
Okay, sir.
Be careful.
Yes, sir.
Whatever is required, you do it, because this will be your last chance.
Yes, sir.
I think you can stop that. Please. No. Stop it. You do whatever you want, you lose the marks.
Sir, we would like to just change the battery. It has drained a little. We are just changing the battery. And just after the change, we'll start with the travel.
So you want to change the battery?
Yes, sir.
Okay, go ahead. And then tell the starting voltage of the new battery.
For sure.
Started?
The initial battery voltage is 16.3 volts.
Ready to go?
Yes, sir. Just a minute, sir. We are giving the command.
Deleted. Seats are there? If you have started, you tell.
manually being controlled.
Okay, I think the team has done their best, and it is unfortunate 3 times they had to manually intervene. I think we should appreciate their effort. Kudos to the team.
So we would like to
So
demonstrate.
Sairam will move to the next team.
So we would like to demonstrate the charging mechanism.
Charging, you want to demonstrate?
Yes, sir.
Go ahead.
Right now, we'll be giving the land command from the via the base station.
So before charge, you tell the voltage.
Yeah.
And after charge, you can tell the voltage.
So the voltage right now is 15.8 volts.
Could you capture any image?
No, sir, the survey did not start because we were not able to detect any corner. So if we do not detect any corner, the survey will not start.
Not detection, just could you do any kind of survey? Acquisition only.
What is initial voltage now for charging?
Sir, 15.8 volt.
Okay.
morning, sir. Myself, I am Kanishk. Good morning, sir. I am Kanishk, team leader of Golden Ratio, and these are my teammates. Sir, we designed a custom-built drone using lightweight materials such as carbon fiber and ABS material.
What is your team name?
Golden Ratios, sir.
Golden?
Ratios.
Ratios.
Yes, sir. Coimbatore, Sri Ishwar College of Engineering.
Why you have selected Golden Ratios?
Sir, our mentor selected it, and it's because of the. Okay, okay, sir. We built, designed and developed a custom lightweight drone, sir, using carbon fiber and ABS materials. And next is, as per the rule book, we just disabled GPS and GNSS. And in addition to that, we disabled internal compass magnetometer, so that in our drone, it can work as a compass denied environment and a GPS denied environment. Due to the magnetic field deflection in Mars, we are disabling the internal compass of this UAV, sir. Next.
Good morning, sir. This is Ditya, and I'll be explaining about the novelty of our system. Before that, please have this. Have a look at it, sir. Yeah. So the novelty one, it's a true GPS denied environment where we have no GPS, no compass, no magnetometer. We have disabled everything, and few sensors help us in autonomous navigation. The second novelty is autonomous dock station, in which we have designed it in a way that it closes the landing area, because in Mars we have severe dust storms and windstorms. It may give us a difficulty where we couldn't land the drone in correct position, so that we have done it in a closed manner so that it protects the layer. And the next novelty is self-aligning of drones. It can self-align itself in the right position. It reduces the error where we can where the charging and landing happens without any difficulty. And the next thing is parallel charging. So we choose parallel charging only because it gives better current distribution, and also the next thing is better current distribution and better battery health life, and also less pressure to the battery. And for this arena, we have prepared it like object detection type of navigation, and the workflow will be explained by her.
Good morning, sir. This is Shahana Parveen. Let's begin with the seeding task. The mission begins at the autonomous dock station, where it acts like a control center of the system. First, the seeded reference images are uploaded to the dock station. Then, once after completing the system checks, the entire mission is initiated by just one click. Then the dock opens automatically, the drone takes off autonomously and hovers to stabilize itself. Now the navigation begins and captures the images. Once if the mission is completed, or if the battery is becoming low, becoming low, the dock returns back to the dock station safely and lands safely. For the detection and logging task, after landing, all the captured images along with their estimated XY coordinates are returned to the dock station, and the autonomous charging happens. Thank you.
Good morning, sir. I am A. Sajendra from the team Golden Ratios. I handled the ROS and autonomous workflows for the drone and the entire dock mechanisms. So in the dock mechanism and the drone's autonomous workflow, so first the drone will capture its home position and the dock position to have a precise land on it. After that, the drone will take off, and it will check the preamp checks if the cameras are connected perfectly to the drone, and the obstacle avoidance sensor is connected. So for the obstacle avoidance, we use it in a LiDAR sensor, so the drone will prevent itself to hit into the net walls, so the drone will never hit into the net walls. So next one is we use it in an OG light downward camera, which will do both processes. The process one is a tag based landing, and another one is an image capturing for the further image processing or force, and then detection object future detection mechanisms. So after that, the drone will take off. It will take off to about a certain height, about 2 to 3 meters. After it will process a lawnmower movement for this bounded area. So we have planned another movement is named as a spiderweb movement for an unbounded area. It will make an golden ratio points, the Fibonacci series. So it will make sure the drone move on based on the series and spiderweb algorithms. So the drone will coverage entire unbounded arena until it complete the charge is complete. Once the charge is get on a low battery percentage, the drone will return to its home dock station and it will autonomously charge. Again it will continue where the waypoint is lifted.
Good morning, sir. I am Sanet Nicholas from the Department of Mechanical Engineering. So my role in the team was to build a battery charging system. Actually, from the norms from the DGCA, the battery has two terminals. The battery has two terminals. This terminal is only for the output for the drone, and this 7-pin connector is for parallel charging, because we have used 6S battery. So in 6S battery, the entire voltage of the single cell is around 4.2 volts, and the minimum voltage is from 3.5 to 3.3. So when we use serial charging moment, the battery life will be affected and it will destroy the entire drone. For example, if the drone is in nearby, we can able to change the batteries if the battery is in bulge condition or not. So that we have custom built the process with magnetic pogo pins. So if the terminal from north and south from the magnet, it will never be attracted by the drone. So we have an inbuilt docking system where we have an alignment inside the drone. If the drone turns to in yaw movement for 20 to 30 degree, it will automatically align the drone and the charging process will be happen. And from the OEM of the LiPo battery, serial charging is not recommended from any brands of the LiPo battery. So we have custom built the battery charging system.
General question. What is the difference between an innovative feature and a key feature?
Sir, in innovation, we have built a custom built battery charging.
No, not with respect to this. Generally, what is the difference between an innovative feature and a key feature?
Sir, lucky feature.
Now, after going through your sheet,
Sir, according to future statistics in our drone, we have a lucky feature called aerogel feature. For example, we have not done the aerogel movement now because of a weight category.
Forget about what you have done. I asked a general question only. General, nothing to do with your system. Okay. Okay. Don't worry. Any question?
So your base station is having a closed assembly, right? It's a closed assembly, the base station. So roof will be opening, I assume. So before the drone taking the flight. So how this is coordinated between the flight and the door opening? How do you plan the door opening to the base, the drone flying?
Sir, one more time.
See, how do you coordinate the two actions? One is a drone is lifting, so drone is inside the base station, right?
Yes.
And it is a closed assembly.
Yes.
So how do you coordinate these two activities? One is a door opening of your roof, which is a closed assembly. Another is a drone flying. So how do you coordinate?
Sir,
Top door opening automatically or you'll remove it?
His question is, what is your sequence of operations when you lift up?
the sequence of operation is the drone is initially charged in movement. After that, the drone first mention the dock to discharge the batteries. So the drone will, the dock will make sure the charger is discharged. After that, the drone command to the dock station to open itself. So the dock station will open the side slider first of all. Then the linear actuator inside the dock station will open the rooftop, sir. After the rooftop is completely opened, the dock will intimate the drone that the dock was opened completely successful. After that, the drone will calculate its position and the coordinates. Then the drone will make sure it is armed and the drone will become takeoff. Now, after the drone entering the navigation phase, the dock is not closed, it will remains open itself. After the drone complete its survey until it reach all the corners or until it reach its RTL mode for a battery fail safe, the drone will come to the home station safely and land itself based on the tag detection. After the tag detection, the drone will command the dock station. I have landed on the dock station. You need to close the dock station. The dock station will make sure the dock rooftop is closed first of all. Then the slider will align the drone. The charging mechanism will start restart it to charge the drone, sir.
So drone is the commanding?
Yes, sir. Drone is commanding the dock station, sir.
Okay, fine.
See that open condition only, na, till that survey completes, that is open condition.
Yes, sir. That was the dock
Again,
station.
once it is landing, then it will close
Yes,
back.
sir. Yes.
Okay, your activity completes after charging. You are closing the that doors.
So before charging, the docks will close. Sir. After that, only the charges happen.
Okay, okay, right.
Okay, best of luck.
Okay, all the best. Go ahead.
Wi-Fi connection.
Okay. The drone is connected through remote display to my. It was Wi-Fi connected.
Okay.
Sorry, the password very young.
Ajindra.
Can't touch. And
Sir, first we initialize the transfer in these commands, then we start the whole glitch. What is that? We need to initialize the start for okay. Then we click the autonomous down. Okay. Now which one is connected to?
Sir, this was the connector.
This is connected to
Drone, sir.
So telemetry is here. And now anything you have connected there for the screen? Connected. Okay. Go ahead. Output images. This system, sir. Output images. You have taken the direction and heading. Yes, this is also not. No, CD I have to give.
Seed image loading.
So they are requesting the net to be along the boundary, very near, close to the boundary.
No, they want it near the boundary or away from the boundary?
Near to the boundary.
Why? No, but net is only put for protection, not for your identification.
No.
Nothing to worry.
Okay, sir.
Don't worry about the net as long as you don't hit the net.
See, it is not that strictly you should not cross the yellow border. Okay, it's you should not like leave the boundary. That's it. So you can still the net will work. Maybe a few.
It is for protection for your drone. That's all. Okay. Go ahead.
Now, Sairam, what is the seats given?
137.
Yeah. Heading is towards the north. What is the XY definition?
Seats are 137. Heading direction is north.
Sir, the X was north direction and the Y was west direction. Plus X and plus Y.
X is towards the north.
North, sir. Yes.
Y is towards
west, sir.
West. Okay.
Okay. Whenever you are ready to press the button, please tell us. And once you press the button, everything should be automatic.
ನೆಟ್ ಟಚ್ ಮಾಡಬಾರ್ದು ಬಿಡ್ರಿ ಅದೇ ಥರ ಹಾಂ Sorry? Initially it's the dock station. Please. Go ahead.
Sir, shall we start?
Okay. You are confident? Everything is okay?
Yes, sir.
Okay, go.
So I'm clicking the button, sir.
Go ahead.
Okay. So the MAV proxy, the agent between ROS and the FC is connected. MAV ROS is connected. LiDAR, the obstacle avoidance sensor is connected. The down camera is connected. And the FC mode is in manual mode. LiDAR is detecting started. The camera FPS is showing about 10 and 8. So dark is sending, the drone is sending dark to discharge it. So lights are indicating.
The charging initial charging is 25.11 volts.
The drone sending to open the dock. So the drone dock opened, and the stack detection node is run, dock portion, home portion, and the survey backs are run. So takeoff node is getting initialized, and the drone was armed. So the drone is waiting for the entry into navigation phase.
No, don't touch. Don't touch.
The drone is entered into the navigation mode. So the current battery percentage is 65. The drone captured about 2 images. So drone captured about 3 images, battery percentage 61. The drone is on land 0. So the drone is deviated from the net. So the drone is deviated from the net, and it's covered about 2 meters side sweep. So the drone switched its land to land 0 to land 1, and the battery percentage is 50, and it's captured about 7 images. The current battery percentage is 46, and the drone is on a land 1, capturing images about 9. The drone captured about 10 images, and the battery percentage is 42, sir. The drone detected the boundaries, and it was moving towards the right side of its. So the drone moved towards the second land, and the battery percentage is 40. The battery percentage is 36. The captured is about 16 images, and the drone battery percentage is 35. The drone is ready for the next right sweep. The drone is ready for the next right sweep. So it successfully completed the next right sweep and holding its position. Battery percentage is 32. It was coming backward. So battery percentage is 30, and it's captured about 19 images. So it was. So the drone battery is 30%. So it was limited by the RTH battery percentage, and battery percentage is less than 30. The drone coming towards its home. So the drone is waiting for the land completion and disarm, but it captured.
They want to take manual, sir.
If you are running short of the battery, use manual control. Don't damage the
show if it happens now only.
Dark close up. East up. East up. East up. Ma'am? Ma'am, once the dark close. Once the dark close, yes. Pass it. Pass it.
Did you return to the base station manually?
Yes.
Okay.
So we can show the autonomous charge.
Sir, drone landing alignment is just in a wrong position. So we say, is there any permission for us to align the drone in front of it? Thank you so much, sir. So they don't know. Sir. Sir, we are initiating the autonomous closing of the drug.
Manually you have put it there, no? After putting it there, remaining part of the processor should be automatic. Automatic, or it should be like sequential. It should happen on its predefined sequence.
It's autonomous. No, it's as an emergency stop switch, safety switch.
Once he placed it, this dock has happened automatically.
Yes,
You can tell if it is automatic. It happened. Now it happened automatically. You can announce.
Because once it is done automatically.
So we have a safety stop switch to make sure the drone is not crashed or crashed by the dock station. So we stopped based on the e-stop switch, and then we have aligned the drone properly into the dock station. Then we release the e-stop switch to continue its process.
What about the image transfer that is happening? The data you have captured during this sortie.
So the current battery voltage 19.62 volts.
Is the starting voltage or already started the
So
charging?
it was the voltage when the drone was landed on the dock station.
Okay, right.
So due to delaying in dock station closing, the image process of receiving and running command is stopped.
So you could not retrieve the images from the drone to your base station, or base station to your
Sir, drone to base station, sir.
Can you do it manually?
Sir,
Can you initiate now?
Sir, yeah, ma'am, we have another option to initiate the transferring of images received from the drone to the dock station.
Yeah, get it transferred.
Okay, sir.
Okay, let us see.
So images are transferring now from the drone to dock station. So the dock station is listening to the images sending by the drone.
So after transferring the images, the remaining process should be automatic.
Sir?
after transferring the images, the remaining process of coordinates, calculation and all that should be automatic. Okay?
So yeah, sir. So the image processing will be continued as an automatic.
What is the status of charging?
Charging is not initiated. It
Not
will be after the data transfer.
Okay.
Sir, the images are successfully transferred to the dock station, sir.
Go for automatic identification and coordinate calculation.
So, okay. Sir, due to the cancellation of the process in autonomous flow, so we need to make sure the dock to initiate the image processing flow, sir, and the charging process.
Charging process has not yet started?
So, yeah, sir. Once the image transfer is data transfer is completed, the charging process is initiated again.
Okay, initiate both.
So we're going to initiate the charge.
Your initial voltage is 19.6. How much time it takes to that 0.5 volts it is increasing?
1 hour.
Are you sure? It takes 1 hour. The 0.5 volts increase.
10 to 15 minutes.
We are not able to hear you. What you want to check?
Sir, I will initiate the charge input is successfully connected to the dock station.
No indication is showing that charging is happening or not.
Sir, because of the connection between the dock and the drone, we are getting connection error.
So you want to connect
Okay.
something?
Yes, sir.
Connect.
The charging started.
No, can you explain that whatever happened actually, that whether it is a manual, it is a autonomous, or that what you made you to make it to work?
Sir, height பண்ணதுனால பிரச்சனைன்னு சொல்றேன். Sir, do the increases of height, it will be disaligned to land.
Alignment, some alignment error has happened,
Yeah,
correct?
sir.
So what you have done that you
So we just aligned the drone to the charger just an inch, sir, to make sure the charger is connected successfully.
Okay, you are not given any additional command.
No, sir, we didn't give any additional command, just align the drone itself, sir.
Okay.
So in the background, the seed image comparison is running, sir. So current the battery voltage is 19.42. Once when the drone is landed, the battery voltage is 19.16 something. The battery voltage is now 19.45, sir. Sir, the problem that we faced before in charging mechanism, sir, that was the one why we raised the when we raised the height of the dock station. So the misalignment was happened, sir. That's why the charging is not initiated properly.
Okay, first initially you told that 19.6. Now we will take 19.4 volt is the reference. Now whether charging is happened, we'll check.
Okay. Sir, the image comparison and the output matching seed images are on background, sir. Once the output is completely availed, it is visible to us, sir.
But why it is taking so much of time?
Sir, the images the drone captured was comparing with all the three images, sir. So the time was taking.
Correct. In the real time, you are supposed to show immediately after the docking is over, you know. Why it is taking so much of time?
That how much is your feature matching and identification and total processing time?
Sir, it was taking 2 or 3 minutes because we totally 19 minutes or 20 images taken from the drone. The drone transfer the image to the base station. After the transfer the base station, and the 16 images are compared with the 3 seeded images and give the final outputs. So the final output will now display, sir.
Yeah, can you display that final images, high resolution?
Charging was finished. 0.5 will be increased.
0.5 reached.
Yes, sir.
What is the now current number?
19.50.
No, 19.4 we have started. 19.4.
Yes, sir. We.
You are not able to connect our screen to your computer?
So the HDMI is connected, the system is connected towards the dock station, sir, so we are not able to connect it.
Okay, you are showing on your laptop.
So currently, it was on a Jetson Nano display, sir, the dock station's display.
Now don't worry. Idu connect madbeku. Ellilla.
Sir, that screen was connected to my drone's display, sir, drone's remote display, sir.
Whatever he is going to show on the screen, this camera can capture and it should come on this. Okay, okay.
It's okay, now it is okay.
Slightly zoom it, I think.
Now you show the seed versus image.
So this is the captured seeded image of HR image of high resolution image of seeded image 2 and the low resolution image and this is the coordinates of the seeded image 2.
Now go little slow. First show whatever seed image is given to you. Then the next you show what is your identified image corresponding to that. Then you tell what are the coordinates of that. Three things you have to do in sequence.
So this is the seeded image 1.
This is what is given. No.
This is seeded image 2.
Wait. Concentrate on one.
Sir?
Go
one
back
by
to
one. Only one first you take.
This is
Corresponding to that.
This is the image given to you.
Seed image.
This is the seed image given to you.
Yes, sir.
Corresponding to that, whatever you have captured and identified, you show that.
So this is the HR image of the serial image 1 and raw resolution image of the serial image 1, and this is the coordinates of the...
Listen to me. One image which you have identified corresponding to that seed image, that only you show.
Show that high resolution image.
This is the high resolution image.
This corresponds to seed 1. Right?
Yes, sir.
No, don't put it for some time. Let us see.
Keep it.
Yes.
Okay. Then you have identified the coordinates?
Yes, sir. I will show the coordinates now, sir. The coordinates of the serial image 1, 3.14, 4.89, sir.
1 minute. Can you zoom that? X is 3.14.
Yes, sir.
Plus
4.89.
4.89.
Okay. Go to the second seed.
Serial image 2 is this, sir.
Ah.
And the corresponding output is a HD image.
Ah. Do you feel this is the correct one?
Sir?
Do you feel this is the correct one? Corresponds to seed 2?
So wait 1 minute.
No, you have a look at the arena. Visually, if you are satisfied,
Not satisfied.
you can look at the arena.
Sir,
Do
no,
you-
sir.
No, do you feel this corresponds to seed 2?
So serial image 2 is matched with this.
Matched with this, computer has done them. What I am telling you, what is your view? This is the correct seed?
Are you feeling this is correct matching?
Look at the arena once. Okay.
No, sir.
No. What? You computed the coordinates?
Yes, sir.
Give the coordinates.
Zero 0.92, 2.92, sir.
2.92.
Okay, go to the third one.
Sir, this is the serial image 3.
Okay. Now you show your image.
Sir, the corresponding HD image.
So this is the correct one?
No, sir.
No. And computer matched?
What, sir?
Computer matched this with seed 3?
Yes, sir.
Our computer
Coordinates, sir.
Coordinates for this.
Matched this image with seed 3?
No, your software is telling this is same as seed image 3.
No.
Okay. Tell the coordinates.
Yes, sir.
Tell the coordinates.
1.39, 5.59.
Okay. Now, answer my question carefully. Out of 3 seed images given to you, how many you are able to identify and match?
So once.
1. And its coordinates we can take for granted. One correct identification and 2 false identifications. Am I
Yes, sir.
correct?
Yes, sir.
Okay. Good. So, anything else you want to do?
So
is there any possible to move for the next another sortie for us, sir? Possible time for us?
I did not get. What is it?
Sir, is there any possible time for us to for second sortie?
Second sortie.
Yes.
How much time you need? Total time.
Sir,
Total time from now.
Sir, we required about 20 minutes to.
Total 20 minutes. Correct?
Yes.
Now it is 12:15. 12:35, you have to show all the results. Okay?
Okay.
Go ahead.
Sir, charging going to. Excuse me, sir. Sir. Sir, the charging was almost to finished. Going to finish.
Voltage it.
19.87.
But is it adequate to take a sortie or?
You want to change the battery?
We want to replace the batteries.
Yeah, okay. You can go ahead. Charging we consider. Okay.
Thank you, sir.
You are changing the battery now, no? Quickly. Okay.
அது ஓப்பன் ஆகி அந்த எமர்ஜென்சி சுவிட்ச் ஆஃப் பண்ணுறா அந்த மாதிரி ஆகும்.
Sir, they want to abort the mission. They don't want, I mean, they don't want to continue. they require a lot more time, around 45 minutes, so they are not.
Okay. If at the end, if some time permits, we will give you another opportunity. Otherwise, we may not be able to accommodate. It depends on the time available between the afternoon function and now. Okay?
Okay, sir.
Thank you. Thank you for your effort. Good effort. Okay?
Thank you, sir.
Thank you. That team can come and weigh their drone and take the lot.
Next team, you can bring your drone and weigh here.
Go. Hello. Japan sir. Yes sir.
Yes, battery is in the battery. So 1765.
What is your team ID?
10943. 943. Galactic Gearhead. Galactic Gearhead.
You take 1/6 from this.
Yes, take it.
What it reads?
It's 90 north. 90 north.
Which is the front of your arrow?
It is in the front.
That arrow should face this direction.
Okay, what direction? Okay, sure.
Go ahead.
Yes.
After some time, in the middle of your setup, either entire team or a few people can come here.
Yes.
And give us a brief for 3 minutes.
Okay, yes. Sure. Thank you, sir.
Take this.
connected HDMI. Which is telemetry? Telemetry. Telemetry there.
So, good morning, sir. We are Team Galactic Gearheads, Team ID 10943. We are second year BTech students from Pune Institute of Computer Technology. So, for the problem statement proposed by IRoC-U 2026, we are here. Okay. We are here with our proposed solution, the Netram. Netram is our indigenously developed ascent system, which consists of the two subparts, that is the UAV and the base station. So, our UAV is basically a quadcopter, which consists of the flight controller Pixox 6X Mini, and for the onboard flight computation, we are using a Raspberry Pi 5. With Raspberry Pi 5, we are using a monocular global shutter camera for the optical flow and also for the imaging purpose. So moving forward to the other half, that is the base station. So on the base station, our whole computation happens, like the live detection and the post-landing validation, all happens on the base station. So our drone acts basically as a surveillance device. So it's first basically takeoffs, surveys the whole arena, traverse it, and it lively transmits the whole video frame to the base station through the WebSocket. And on the after transferring to the WebSocket, on the base station, the live detection happens. So our drone basically covers the whole arena, and so we process the thousands of frames at the base station. And after processing that thousands of frames, then the post-landing validation happens. So on the other half of the base station, consists of the three main processes. That is the mechanical alignment process, second is autonomous charging, and third one is the data validation. So our mechanical alignment process consists of the pushing rods, which basically corrects the yaw after landing. That is the basically passive yaw correction. So what the passive yaw correction do, it makes the drone ready for the charging purpose and also make it ready for the next sortie. Like it aligns it properly with the base station. So during the next sortie, it don't face any problem. So next part is of the autonomous charging. So it's our novelty also. We have indigenously developed a charging system which can charge a 3S LiPo of 5500 mAh in nearly 18 to 20 minutes. It doesn't require more time. And after the 18 to 20 minutes, we are ready for the next sortie with the same battery. The third step is of data validation. Before talking about data validation, I would like Bharat to explain to you so much more about the indigenously developed charging system.
So the charging system we have basically developed consists of an SMPS circuit on the base station connected to a PMOS cutoff circuit. The cutoff circuit has three tasks. It basically ensures that the charging plates are completely isolated in case the drone incorrectly docks or is airborne or fully charged. So, and on the UAV, we have implemented a battery management system which performs active balancing over passive balancing. So any issues related to heating are completely eliminated on the UAV. And as he said, we are able to completely charge the UAV battery from 11.1 volt to 12.6 volt in around 18 minutes. And the 0.5 volt increase can be done in mere 5 minutes. So, and even during our practice matches, whenever we were practicing on our own arena, we didn't even change our batteries. We basically were charging our batteries on our own charging system as well, because they were charging our batteries really fast compared to the LiPo chargers which are present in the market, and so that we could do multiple sorties and multiple practices.
So now you got the basic idea about our ascent system and the indigenously developed charging system, etc. So I would like to demonstrate you the GUI that we have developed that will show you all the information. Okay.
Yes, I can explain that. Once you are ready, one of our volunteers will give you the seed images. Once you load the seed images, the opportunity for you is to press the button. Press the button.
Yes, sir. Our system is fully autonomous.
Listen to me. After pressing the button, everything should be automatic. No manual intervention, unless you see some problem with the drone. No manual intervention till you show two things. One is the image matching with the seed given to you and the computation of the coordinates with respect to your base station for all 3 seats. That is first action. Second action is to show auto charging without manual intervention. Any manual intervention will reduce your mark. Otherwise, you will get full marks. Clear? One button, full activity. Okay.
On our GUI, there will be only one button, that is start the mission. There will be no manual intervention after it.
Press and forget.
Yes.
That is the motto. Press and forget.
Ifshita, show the GUI website. Connect the batteries. Sir, with your permission, should we start the demonstration?
You go back. No. You want to tell something?
While the drone will fly, I will comment like.
No, you go back. You can give the commentary from there.
Okay.
You go back to your team. They need your support also. So we'll see from here. Because if you are standing here, we cannot see the drone. Okay? Go ahead. All the best. Okay.
Thank you, sir.
First get prepared. Dhruti? You want PNG or JPG? I have PNG. Should I take all of them? You take all of them and copy onto desktop. This is on desktop.
Base station is launched.
So this you can rename ABC.
Should I just rename it as P1, P2, P3?
Yes, you can do.
Or
You can do it.
drone is connected? GUI you can show them.
Now, if you are not operating, just give little space so the observers will sit. You can see till this side. You can leave space. Little place is required.
Are you ready?
Sir, CD images are 1 to 7.
Okay.
Heading direction is.
So north will be X for us, positive X, and east will be positive Y.
Okay.
Okay. Towards the is positive Y. Towards the north is positive X.
Their heading direction is north.
Okay. Correct, no?
Yes.
Your definition. Okay. Right. Go ahead. All the best.
Initial charging.
So the battery voltage currently is 12.54, and we'll be starting our mission now.
Fully charged, correct, no?
Yes, fully charged. 3S LiPo battery.
Okay.
So the failsafe will trigger at 10.9 in-flight voltage. So do we have permission to start?
Yeah, go ahead.
Okay. We'll start in 3, 2, 1. So now our UV takes off to 3.75 meters, and it will start correcting its yaw based on the IRoC marker on the base station. Now it's starting its survey. So the drone is currently searching for a corner. So it has found the corner. Now it will start its forward survey, lawnmower style sequence. Now it will perform a right sweep. Now a backward sweep. So while it is surveying, it is transferring all the frames it is detecting to the base station for live detection. As you can see on the website, the live feed is also shown of the UAV. So now another left sweep and a forward lawnmower sequence. So the current battery voltage is 11.48. So it has detected the front boundary and will start its left sweep and backward movement. So now it has completed its scan and will begin the RTH procedure. So this is a return to home. So our return to home mechanism works by a ultra-wideband sensor, which helps the drone understand its proximity to the base station. So it has detected the IRoC marker. Now it will begin centering and its descent. The current battery voltage is 11.16. It has corrected its yaw actively in air and will begin its descent. So it has begun its descent. Now it will switch to a smaller IRoC marker for precision alignment at the center and it will land. Now the sortie completed command is sent to the base station via the drone, and it initiates autonomous docking and charging.
What is the current voltage?
So the current battery voltage is 11.43. So the landing voltage was 11.3. Now the UAV is docked and the pushing rods will start homing, and then autonomous charging will begin. So as you can see, the battery voltage is increasing. It was at 11.3 at the during landing. Now it is 11.56. So now that the detector images will show up here, then there will be validation has begun processing.
Actually, as I said in starting, we are processing the thousands of frames, the whole arena. So the detection is bit much late, and it will come one by one.
Can you tell the status of data transfer?
So the data transfer is happening live. So it detects each frame. So it's taking a little bit of time, but it is detecting the frames. Once detection is done, it will complete validation and will display the results and coordinates.
Okay.
The whole data is transmitted to the base station computer during the live flight only.
We are requesting permission to switch tabs to see the status of the data transfer, just to see how many frames are left to be detected.
Just they will open the backend and see how much frames are in buffer that data is processing.
Renuka, can you confirm that data transfer completed?
Yes, sir, we can confirm. We can show you how much frames are transmitted there.
Sir, to confirm
what they want to do, I did not get.
Okay, so she wanted to show you, like on the opening the VS Code, the backend is running. So how much frames we received and which frame is processing going on.
Something has to be touched on the PC?
Sorry?
Something she has to do on the PC?
Sir, she needs to just switch the tab window, a
No,
different window.
it is not for the processing, it is only for display, right?
Only for display.
No need, okay.
Nothing. We don't want any additional information.
We are okay with, we can wait, don't worry.
Don't touch the PC. Let it take its own time. Don't touch the PC, show the images.
So as I understand, the transfer is just an additional backup of the data. Otherwise, the processing takes place on the drone itself, right?
No, the processing is taking place on the base station. The drone just transmits the whole data in the real time to the base station. Okay. Now the computation is happening at the base station, so it's a bit much slower.
So it will automatically come the result. That's
yes.
all. Say.
This is the detected frame tabs. Okay. The detected frames will come here. After the detection will happen, the validation will begin. The validation is also going on. The validated features will come here.
Don't worry. We don't need any intermediate data, so don't touch the PC. Okay? We don't need any intermediate data. We want to see the identified seeds and their coordinates. That's all. Okay? We are not interested how much data is transferred.
You want to only demonstrate the frame transfer, how much completed, right? Percentage wise.
Yes, I just want to show.
It's okay. Don't worry. Actually, this mission running is blinking like Operation Theater. Outside it blinks.
Initiated. Here you can see the UAV landed and charging initiated. That is the part of our mission, so that is blinking continuously.
How much more time will it take?
Ma'am, it's still computing the numerous frames.
The battery voltage is currently 11.75 and the drone landed at 11.3.
Yeah.
The data transfer is still happening.
So one of the validated images has appeared, is it so?
Sir, actually that is the detected image. After the drone surveyed the whole arena, it transferred the image. So the base station computer processed it and show that it is the detected image. Then it will be passed to the validation filter.
By detection, you means matched with one of the seeds, is it?
Yes, sir.
So what I wanted to ask is, that appeared long back. Okay, so remaining, I mean, it means that probably you had to parse the entire thing to get one match, right?
Okay, sir. So basically, when the drone take off, it first traversed there. So
no, you speak after the data acquisition is over. To get a match, the entire data it will be trying to do a match, and then it got one match. So, but the first match arrived very quickly. So why would the second and third matches take a lot of time?
Okay, so it is going on sequentially frame by frame. So the first frame contains the earlier flight time. In the earlier flight time, it was containing that feature.
No, whatever you explain now is applicable even for the first validation, right?
Yes, sir.
So, but why did that occur soon and the other two did not? Is it that it is yet to find a match?
That's why we wanted to like just see what is happening in the back
Yeah,
end.
that's what probably you feel that it's stuck or it's.
Yes, yes.
But we have to time out then, sir.
Are you stuck?
Sorry?
Are you stuck or it is going on?
We want to check the same.
First tell me, are you stuck? Without intervening, you cannot go further.
So you suspect you are stuck. Is this a reasonable time for processing, or you suspect that you are stuck?
That's the processing time reason. We feel that it's still processing.
So
but
how much time normally takes? See, the flight was approximately 2.5 minutes, 2 minutes, approximately 1.5 minutes. So what will be the data sizing?
No, Prashant, that's what I was trying to get out of them. See, the first one was matched so quickly. So almost the same order of time only it has to take for any.
So
we would like
to.
to.
Not get. If you are hoping to complete the task without intervening, you take time. But if you feel you got stuck, we will allow you to touch your PC and do whatever you need. So you decide.
Sir, so we would like to just check at the back end what is happening.
You would like to touch the PC. Go ahead.
For one click. Ipshita?
Before that, so that your battery is completed, no? That charging.
Okay. So this is.
Still 150 frames are remaining.
Only 150 frames are remaining now.
Okay. See, the battery is that 0.5 volts. It has come.
Yes,
charging
sir, it
completed.
has increased, and we can even wait like 10 minutes more so that it can reach even 12.6. So that we, even if possible, we can do another sortie alongside.
It's just another process is running. Now 150 frame only remaining. How many total frames captured?
Okay, one seed was detected. Current battery voltage is 11.96. This is the detected feature. Its X and Y is X is 2.178 and Y is minus 3.508.
Can you repeat?
X is 2.178 and Y is minus 3.508.
508. Okay.
Only one got detected. We would like to redo the.
Okay, so sir, in this sortie, due to our model inefficiency, only one got detected. So we would like to do another one sortie within the. Please open the main window, main tab. So sir, now the battery is 12.01. So we would like to take much small time of when the battery will fully charge up to 12.6, and we would like to do another one sortie with your permission.
You want to do one more sortie?
Yes, sir.
Why you could not identify the other two?
Because we didn't identify the other two, so we want to do another sortie.
Okay. Total, how much time you need from now?
So sir, in another 10 minutes, the battery will get fully
You tell me total time. Right? Now you start. You have to show the 3 seeds matching. Total time, how much you need? because we are running short of time.
Sir, we will require nearly 20 minutes more for the entire result.
How much?
20 minutes.
So now we are at 12:57. 120 will close.
Okay, sir.
If you are not showing this, this will be your result.
Okay, sir.
Okay.
Yes, sir. And sir, one more thing I would like to add, we won't touch the drone anything. We won't touch the UAV at any point.
No,
It
no,
would
no,
charge.
listen to me carefully. Whatever you want to do, you do. Again, after pressing the button, again same rule. Okay? Before pressing the button, whatever you want to do, you do it. After pressing the button, you have to show 3 CD pages matching and their coordinates by 120. If you don't show, this result we will take. Is it fair enough? Go ahead.
Sir, as you can see, our cutoff circuit is active now, and it has cut off the battery at 12.6 volt, and we are ready to fly again.
So our battery has been fully charged and we are ready for the next sortie.
Yeah, you can go ahead.
Yes. Now we are loading the seed images, then we will start.
What are the seed images?
So now we will be keeping our orientation as forward facing east.
So your orientation is that X is towards the north?
No, X is toward east and Y is toward south.
Towards south, okay. Now heading is same, no? That heading is that towards the north.
Excuse me, yeah.
Head also changed. Heading also east. Okay, right. So
Are the seed images same?
Sairam, have you loaded the seed?
Okay, so sir, seed images are number 2, 3 and 6.
Okay.
Yes, sir. 236. And heading direction is east. Why 180 degrees is required? Okay, go ahead.
So the current battery voltage is 12.52, and with your permission, we would like to begin.
Go.
So we'll start in 3, 2, 1. So now it has begun its survey after correcting its yaw over the base station. It has found the corner and will now begin its lawnmower sequence. Sideways sweep. So it has found its boundary and will complete its last lawnmower sweep. Now it has begun the return to home sequence. It has directed the ARoC marker and will begin yaw fixing. Now it has begun its descent. So the current battery voltage is 11.32. So it just landed outside. Can we just shift the drone a little bit inside? Two legs landed just outside the rail.
Don't worry about charging, that you have proved already. Acquire the images and show the images.
You can kill the base station. Let it be. Don't touch. Yes.
Don't touch. Acquire the data and show the images.
Yes.
Okay.
Okay, sir. So the computation of the detection frames are going on. Okay, sir. So without spending more time, I would like to tell that in this run, due to the some inefficiency in our detection pipeline, and the scanning was also not proper, so there was no images detected this time. So
no acquisition of the images has happened.
So while flying over it, it did not cover the full feature in one frame every time. So that's why it was unable to detect it.
Okay. We will take your first shot as the result. Okay.
Yes.
Okay. Good effort. Okay.
Thank you.
Thank
Sir.
you.
Thank you, sir. Please come here. We will take a group photo. Just bring the UAV with us. Sir. Yes, sir. Actually, open the VS Code once. So sorry, sir, but actually our detection is going on in the background, like 1,000 frames are in buffer. So until the group photograph will go on, can we keep it on? Like, okay, just keep it on. You guys come here. There are some images of the last part of the arena that it's still getting processed. Okay, sir, we will let it process. Do one thing, open the tab sideways. Yes, sir. Please come here fast. Let it run in background. Om, bring the UAV. We processed total of nearly 4,000 frames, 4,000 images. Just 300 more. Okay. Yes.
Don't mention how fast you got remoted. Don't mention the Tokyo.
We now move on to the mainframe systems, and I invite Naval Gund, who was the right-hand person for the project director in getting everything done, bringing things together, and talking to the scientific community to get things done completely. So we'll hear from Naval Gund on the challenges he faced.
Good afternoon to all. Thank you, Dr. Shiv Kumar. You heard all about the payloads. So payloads also had a lot of restrictions. So the configuration of astrosat goes on the constraints of the payloads and some constraints from the subsystem. So configuration starts from the FOV requirement of all the payloads and sensors and antennas, and then the multi-spectral observation of payload needs the co-alignment of the core of the payloads, like SST, UZT, and then UAT, where SSM accommodated core payload from the top end, and one more constraint was the thermal stability of the payload, UZT and UAT, thermal distortion. So because of their height, we decided to mount it on a single plane. So both SHT and UZT, they are mounted on a single plane, and we took the structure from IRS-15K, and this structure was not sufficient, so we modified the structure to meet the mounting requirement and then the heaviness of the payload. The total lift-off mass of the astrosat is around 1,512 kg. Out of this, the payload mass itself is around 750 kg, more than that. So 50%. First time we were lifting such a heavy payloads on any IRS structure. So the structure needs to be reinforced so that it gives a good rigidity to the payloads and give a good frequencies for the payloads, so that there is no dynamic coupling between the structure and the payload. The total, in addition to this, we had the requirement from the subsystems like the star sensor and all. So the mounting of the star sensor was
suddenly got burned out a few hours ago, and they are not working again in the base station. So
we could achieve that. So without
we have simplified the base station. It was 90-80% working in the morning, some minor tweaks here and there, but 2 hours ago or 1.5 hours ago, because of some load, because of the new tuning and all,
the payload, because payload itself is having a lot of thermal constraints within the system itself.
It can always cut now. The landing will be precise. The only problem, it can also charge now. The only problem is alignment, because for alignment the motors have to start, and the 4 motors have to start.
So we have a good isolation from the main platform.
It will land with good alignment, but for the piece to connect, the motors need to start, and for the motor need to start, the motor driver needs to work, and that got burned out. That got burned out.
Titanium spacer between this center structure and the
parts,
so that the thermal difference are met. To tell you the complexity of this one, we have used around 800 to 900 meters and 200.
So in the end, when all things are done, can we do the manual alignment?
So this will tell you how much there is the thermal design and control is there for this structure as a whole. Coming to mechanism, we had main mechanism, solar panel mechanism. We had initially started with 3 panels to generate the power, but as the project continued, there was an increase in power requirement both from the mainframe systems and from the payload. So because of that, we changed the type of solar cells used, and we reduced the number of panels from 8 to 2, and we used multi-junction cell. The because of which we gain around 5 kg of mass because of this changes. Then since we cannot get the power from only from this, we had used. You want to give a brief?
Yes, sir.
Go ahead, 3 minutes.
Okay, sir.
So this how the power.
Yes, sir. Is it connected? Sir, so good afternoon, everyone. We are team aerial robotics from IIT Kanpur. In very brief, our drones have the whole task as it is divided into 3 specific sub-problems: charging, autonomous, localization and mapping without GPS, and feature mapping. And then we can also say precision landing. So in very brief, I can just tell you the main algorithm which we are working upon. So for charging and alignment, autonomous, for alignment, we are just using a geometry of the drone. When the straight rails come at a specific location, the drone get always aligned in a specific location. And for charging, when the location is achieved through motors pushing the rails, aluminum rails, then the pogo pin connects to the charging plates at the landing gear, which will start the charging at the drone. And when the charging is complete, the rails retract themselves. For simultaneous mapping and localization without GPS, we are using the ISRO framework. Our main sensor includes the 435i real sense camera and MP LiDAR and then the basic sensor which is already included in the flight controller, IMU, gyroscope and compass. So these are our main stack. And the algorithm is ISRO, which is using all 3, the data from all 3, pushing them into a extended Kalman filter and giving us the most accurate results. And because our camera is pointed downwards, so it is seeing the same key features in the 2 parallel sweeps. So the overlap area between 2 parallel sweeps is quite large. So it finds the same key features, which helps it in recorrecting the error. So the error doesn't integrate over time because the camera is facing downwards. So this is for the mapping part. And then for the feature detection part, we are using the main algorithm, which is Dino. In very short, what it does is, any image have very low level features such as geometry, texture, color. So the Dino computes a vector of all the parameters and match the cosines of them with the arena frames which we are getting during the survey. So whichever arena frame gets the maximum threshold for the specific image, it will map that to the arena frame. How that specifically works, Gaurav, you can explain how that specifically works.
So talking about how Dino V2 works, so it's a transformer-based vision detection model. So what it does is it basically calculates using K-means clustering. We optimized it to basically categorize the background into 8 centroids, which represents a higher dimension vector, which the transformer outputs. So what we are computing is, we are computing a novelty score. Suppose a feature comes, so the embedding that is generated by the VLM for the feature would be very different from the background embeddings. That is, the cosine similarity of the 2 vectors in the higher dimensional space in which the Dino V2 produces the output would be very high, would be very low, cosine similarity. The 2 vectors won't align much with themselves. So based on that, we are separating the features from the background. And based on that also, we are identifying the region of interest and then matching the embeddings that came from the reference images, 64x64, with the low resolution image that we are downsampling in 126x126. Sorry, 128x128. Apologies.
So from the go signal, when you press the button, whatever you have explained, everything is automatic or any manual intervention is required?
As our base station is not working, that might be we have to do manually here. But apart from that,
but what you have to do,
apart from that,
you have to intervene in between.
Because our base station is not currently working in a proper state.
Reason you leave it.
I give you the
what you have to intervene.
Alignment. Charging it will happen. Precision landing will happen.
Charging will happen.
Landing will happen. Landing will always happen at a very precise location. For the ports to connect, the motors have to move, and for the motors have to move, the motor driver has to work, but our motor driver just got burned out. So the rails will not move, which will not connect the ports to the square plates at the landing gear.
So you have to do something on the PC or on the physical hardware, something you have to do?
Physical, we have to move the rails so that the ports get connected to the
So you have to
gear.
move physically.
So
after that it will come automatically?
After that it will come automatically. So from the very start.
Good enough.
What is the data transfer will be happen now?
Data transfer will happen automatically.
Automatically happens.
Yes, sir.
Base station only that all the data you
All just alignment. Everything else will happen automatically from the very start. Takeoff, survey, swapping, feature images, arena images, storing, then transferring it to the base station, then validating it, then matching it with Dino, then reporting it to the output. Everything is.
What is your planning of the trajectory?
It's a lone mover. The drone will will go in an arbitrary direction. Once it finds the coordinate corner, from that point it will just go into a lone mover algorithm. Just sweeps snake-like pattern.
Okay, only at the ground charging point only you cannot do the autonomous.
Yes, sir. We cannot connect the port.
Port connection will that only manual it.
That only is manual.
Okay.
That actually is luck. If by luck it moves
Okay.
there, then
All the best. Go ahead.
Thanks, sir.
So there we could see by the consistently mopping of the floor and restricting the movement of the people, material, we could able to achieve some 8,000 cleanliness index, though the specification was 1 lakh. So from 1 lakh classroom, we could able to achieve around 7,000 or 8,000. So the requirement was around 10,000. So these are all the challenges we could show the input able to overcome. Because of which we are seeing the quality product in the field and that we are reaching the best. Thank you.
We now call upon Panji. There was a challenging phases mission. By the way, there was a 6th payload on AstroSat called CP and the charge particle connector. So now and Dr. Pandian was particularly worried about its role and relevance for addressing the CA. Basically,
give duplicate. Whether it has detected your SCMA is not
I
connected.
was not a mission person, but I was installed as a mission director by Dr. Goyal at that time. He had some kind of hope on me, so I had to work hard to meet this requirement. The first thing we faced from this payloads are the various requirements. So whenever I see professors, I get trouble. And all the professors who came, they demanded so many things. And every time they come out, you see a multi-wavelength space observatory, and they come out with so many requirements. Professor Tandon says 45 degree unavoidance angle, and Professor Sterkison comes and says only 30 degree unavoidance angle is good enough. Then later, we sat through something like 3-4 meetings and finally came out with that option of unavoidance, sun angle avoidance of 45 degree, avoidance of bright edge limit 12 degree, ram angle avoidance of 12 degree, moon angle of 12 degree. Apart from that, any bright object do not come into the field of view of any of these this one. This is the initial this one. So much of constraint.
Sai, can you announce the features?
Understand their language, and I have to inform our spacecraft engineers and the spacecraft operation engineers how to put these things in the spacecraft so that all these things are met while operation. So that was the kind of thing to start with. Apart from that, we also have the soft and things which are mounted along the yard. They have that 45 degree, 50 degree cone angle avoidance. So you have to have a 50 degree sun avoidance. So if you see all these
You have connected the drone to the system.
spacecraft was very difficult for
Connect the drone to the system. Do your prelim check, then ask for
I have to
CD.
make them understand. And then put those things in their subsystem. It should work. properly also, which shows the operation. So the language codifying has become a very major challenge, as our PD professor told. This was the initial problem we faced, right? That was the challenge during the conceptual stage. Then comes the control challenges. See, control requirement, spacecraft orientation pointing should be 0.05 degree, 0.03 degree is goal. Drift rate was very stringent. Then maximum satellite rate was given 4 degree per second, which means we had the reaction wheels which are of 5 Newton meter capacity, and the satellite is 1500 kg satellite, and you cannot have very high rate. So we have to limit that maximum satellite rate there. Then jitter is also very stringent here. This has to be met. But then came that 4 payloads are co-aligned about the positive roll axis, and one of the payload is about the axis, and it is rotating as SSM is rotating, and when it is rotating, Professor Tandon came and told, not at all possible. When UVT is viewing, the SSM cannot rotate. Then they came out with the step and stay idea. Not only that, how to compensate that motion. Jaswinder Singh came out with the SSM motion compensation algorithm and put it in this one, and then that part is taken care. Then the most important thing is that we have to worry about maneuvering the satellite, because it is a sun point and it's an inertial pointing satellite. One inertial pointing to another inertial pointing when it goes. Two axes about which the sensitive payloads are mounted, apart from the star sensors. I have to avoid these two sides. Two sides have to be avoided while rotating from one pointing to the another pointing. We have to think about a particular type of large angle maneuver, which is constrained about two of the axes. Then Koral and Juglikar team worked on that. Then we came out with a method of maneuvering in space without seeing the sun. Okay, one more thing. So that is the next, this one. Apart from that, this calibration exercise for the first 6 months, all the payloads have given a particular
TB is ready to start.
This was not easy to do on daily, day-to-day basis command.
We are loading the seed images.
Huh?
We are loading the seed images, sir.
Abhika, we have to start. We are running short of time.
I have told them, sir.
Otherwise, we have to postpone.
Yes, sir. Yes.
About one of the payload if you point, then it will complete that in one go. Like that we have managed it. So this is one of the challenges we face. Manage this one. Apart from that, anyway, naval design was not the usual one. It has to be redesigned in order to meet all the requirements.
Sir, seed images are 136.
Similarly, SSR also. Thermal features, number of features,
Heading is east. Can they define that XY coordinates?
Directions.
During the operation. So all these things have been put together and we made
No, P3, P1, P2 you can put.
something like 2-3 years. And with that, as per
P3, P2.
AstroSat proposed
It's okay. Don't worry.
all the processes, they made
We want your best only, so don't.
dynamics modules as well as command sequence generation software. It was not easy because each payload has to be given a particular type of importance, and accordingly it has to be sequenced. All these things were taken place, and these ground segment meetings took place with hundreds of engineers and PAs of the payload together And we came out with the data processing level 0, level 1 software, as well as HTML software, and the growing MTech database. One of the young scientists from mission came out with that idea, and they all put together. Today it is working for 10 years. I believe that all this effort has really helped in making the satellite work for this many years, and it is producing very good. I thank the administration who allowed me to be the DPD leader for this. I wanted to thank some of my teammates like Coral and Jessica for the control, and Leo and the team from operations from scratch. They have taken wonderful care of the satellite, and Nagamani and Dakshayani who have given me 200% support from Dynamics, and this was a very good experience I had. I really enjoyed this satellite. Thank you very much.
I'm going to listen.
I now call upon our earlier program director and person in charge of mechanisms on AstroSat. You already heard there were numerous mechanisms on AstroSat. So, Nagesh,
good afternoon. I thank the organizers for making me a part of this historic occasion. I'll be speaking on behalf of mechanics.
So the front direction in which the camera is facing, is the Y-max. So this is
Y
the Y
plus. Heading
Y.
direction is Y plus.
Y.
Y. Okay.
And then this direction is X.
This is X.
So this is Y. This is X.
South is X. Okay.
Yes, sir.
Towards the south, X. Towards the east,
this
Y.
was X. This was Y.
Okay.
Now, as far as challenges are concerned, the UV telescope cover mechanism was totally new. The SXT mechanism was also new.
Yeah, please start.
Also new. As far as the array is concerned, this was modified with respect to our standard 3-panel array used in IRS satellites. Now, coming to the design requirements and challenges, as far as the telescope cover mechanism is concerned, this cover is supposed to ensure that there are no contaminants or volatiles which enter into the telescope payload, say in ground and maybe around 60 to 70 days after launch. And this cover is supposed to act as a sun shield in case of UV. And as far as SXT is concerned, the cover opens by around 275 degrees. Now, because of the presence of optics in these telescopes, we were not supposed to use pyro devices, which is our standard release mechanism. So we had to think of some new release mechanism, which is supposed to release the hold down from the...
Can you please start?
So we thought of...
Sir, the router is not connecting. Just a minute.
Finally, we selected the paraffin actuator, which does not produce much shock. Now, as far as this particular paraffin actuator is concerned, because it's a new development, our management initially insisted that we have some imported ones as a backup. Now, parallelly, we were developing this paraffin actuator. In one of the meetings, I remember our project director told that once you have got the imported, you will not definitely continue with the indigenous development. But in fact, we promised him we will use the indigenous one only on these telescopes, and I'm happy that we have used the indigenously developed paraffin actuators. It had to undergo rigorous qualification tests. Now, coming to the other challenges were the materials that we use on these mechanisms, they had to be, there was stringent contamination specification and control, which we had to ensure by proper material selection, then cleaning procedures, baking, etc. Here, between the door and the interface ring, we had to have a material, the PML and CVC.
Sir, we can start with the command of enter, as you suggest.
Go ahead.
Go ahead.
Particular.
You can also see the logs.
Yes, sir. Sir, beginning the startup sequence. It's getting start.
I did not get what you want to do?
It is going to take off in a short while. All the nodes are running.
No, why that control unit you are holding?
Sir, for emergency purposes only.
For emergency?
For
okay.
kill switch only.
Okay, go.
Sir, the router again got disconnected. We have to reboot the system.
What you have to do?
The router again got disconnected, so we have to reboot the system. Because
Okay,
the router got disconnected.
okay, reboot.
Hey, router कुछ issue है क्या?
You can reset the router also if you
किसको reset करना है? पता लग जाएगा. अबे altitude कितना है? तेरा वाला फाइनल कोड कौन सा है जो क्लियर है? क्या? I guess something से build करना पड़ेगा उसे. वही तो. हम सब कितना टाइम लगेगा? 10 minutes. I think some file got missing. We have to build that again. It's going to take 10 minutes. 10 minutes. 10 minutes. You can take it. Okay, sir. Thanks.
Start after 10 minutes.
Sir, we are trying our best.
Our type is over. This is a gray state we are doing. They are also under pressure.
Yes, sir. Thanks. Wait, 10 minutes. 5 minutes. चलने वाला भी सर इट इज सर इट कैन स्टार्ट नाउ The radio telemetry loss, so the kill switch won't work. So safety kill switch, turn it off. Sir, actually some telemetry issue is going on. The drone disconnected with the radio, so the failsafe got active and it automatically kills the mission because the drone disconnected with the radio.
So what you are going to do?
Sir, what's the question?
What you are going to do now?
Sir, we are trying to start that again.
You want to start again?
Sir, it binded to someone other's radio.
I did not get. You want to start again?
What was the question?
Hello. Is there anyone here having RC control? Is there anyone in the arena having RC control? They are saying some other remote has been connected to their drone, sir. If anyone brought unintentionally, please switch it off. Let us complete the team.
Anyone from the viewer lobby? Anyone is having RC? If it is there, please switch it off.
Around, yes, sir, possible. What are we trying to do now?
Start the mission again after connecting it. After
You are
you
able to
connected
connect
it
now?
again, you can see the signal
You
here.
can connect now?
If you are hoping that I'm able to not connect now, this is the first time it happens. So the like video connection got lost, and exactly switch or back to the only return. Sir. Sir, excuse me, sir.
Are you ready now?
Yes, sir.
Sir, they are ready, sir.
So we are
Go ahead.
start.
Go ahead.
बाद में kill कर दियो, kill करेगा वो इसमें नहीं आएगा। बैटरी हो गई।
Again lost again signal. I don't know. I think it's the antenna problem.
Sir, the radio control signal again got lost and the fail save got triggered.
Okay, try again.
सिग्नल अभी आप देखो वापस आ गया।
तो ये जब उड़ रहे तब सिग्नल पता नहीं कुछ प्रॉब्लम है सिग्नल सडनली किल हो जा रहा है हमारा पहले कभी नहीं होता अगर हम किसी से
Is it possible like you totally disable RC anyway, you take a chance?
Yeah. Sir, like it will be very risky if we don't have any type of control here.
Anyway, net is there.
Huh?
Net is there. Anyway, you take permission. RC is there to disconnect.
Because you are running out of time.
I don't know. You take the permission.
RC field से disable कर सकते हैं.
कितना टाइम लगेगा
ज़्यादा टाइम तो नहीं लगना चाहिए. करना एक मिनट एक एंटीना ले आया सिद्धेश फिर ट्राई कर लेते हैं. मेरे को एंटीना का शो
RC battery is not weak, right?
RC battery local है.
We are flying it outside and it was perfect. I don't know what is the problem. You can change the channel. I'm just trying to get this antenna and actually the antenna was broken. I don't think it will work.
कब होना चाहिए
But मुझे नहीं पता maybe.
कनेक्ट हो गया
हाँ connect to हो गया. हाइट बहुत आ रहा है 1.3 है रिबूट करना होगा फिर सिस्टम
चलो यार जल्दी करो रिबूट
बैटरी निकाल के
भाग 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 जनरल डाला
We are also trying our best to give you accommodate you.
क्योंकि एक्चुअली 5 मिनट तो लगेगा शुरू होने के बाद वैलिडेशन में टाइम लगेगा एक्चुअली 5 मिनट कंप्लीट हो जाएगा
Why every time you have to update as a system? Every time you have to run the every time you have to run the scanner. Will work, but just ensuring everything like running separately. Things that are ठीक है SSH करके तू SSH कर ले तो स्टॉप पे आ जाएगा तेरे को बैटरी लेटर टेक ऑफ करते टाइम फिर से सिग्नल लॉस हो गया मैं एक काम करता हूँ मैं एली के अंदर जाता हूँ मैं एली के अंदर जाता हूँ तो मैं सिग्नल पास है तो आ जाए
You want to go inside?
हाँ फॉर द सिग्नल
इसमें तो कुछ सिग्नल है. If it goes there, it will lose signal, right?
दैट इज द प्रॉब्लम
अगर ये नहीं हो तो फिर से मैं मेरे में चला
बट मुझे नहीं पता अगर ये अटक गया तो लैंड कैसे होगा
अटक गया तो लैंड कैसे होगा तो टूटेगा फिर तो ऑप्शन ही नहीं है सेकंड राउंड का तो फिर होपिंग की पहली बार में हो जाए
You can kill it through your laptop also, right?
we can kill it but it will not land it will just remain in here duplicated session
Once again, can you please check the input and output for it?
Sir, excuse me, sir. We are trying to start again.
Last chance for you.
So if the radio doesn't disconnect, we can.
No, this is the last chance for you. After this, we have to wind up because
okay, sir.
we are short of time. That is the whole reason. Okay.
Sir, don't get takeoff after getting armed.
Yeah, I think probably maybe because of the overweight, it is not able to take off. I do not know, but sorry. Already you are in the grace time. Because morning you are supposed to come.
Sir, but our radio failsafe is getting disconnected again and again. Can we once try without radio failsafe?
No, but I don't think you will take off. Okay.
Yes, sir.
Are you sure you will take off in another 5 minutes?
No.
Hi, how are you?
Sir, we can try for next 5 minutes without the radio failsafe.
You are seeing now. You are seeing the stage. Already arrangements are going. By
Yes.
the time
Yes,
the
sir.
chief guest arrives, we have to clear. Okay. 5 minutes I will give you.
Okay. जैसे रेडियो डिस्कनेक्ट होता है फेल से ट्रिगर हो जाता है अपने आप ही
जीएसटी कनेक्टर और तुझे पता है वो जिसमें ऐसे पिन घुसाते हैं ऐसा कनेक्टर होता है मैं जाता हूँ ठीक है चाबी दे
कनेक्शन हो गया, अब बस स्टार्ट करना है सारा।
दिखाई
कनेक्ट नहीं हुआ।
उसको थोड़ा स्लैंटेड है, वो थोड़ा सही कर दो उसे। नहीं वो ऐसे कैसे है नहीं बैटरी, अरे ड्रोन थोड़ा स्लैंटेड है। ड्रोन है स्लैंटेड है, कोई फर्क नहीं पड़ेगा। ठीक हो गया कनेक्टेड। हाँ ओके, अब जल्दी करते हैं पहले।
एनी अपडेट?
हाँ कनेक्ट हो चुका है, बस फाइनल अप्लाई करना है। एक सेकंड रुको,
इन्फॉर्म माइक में बोलिए, बताइए मैं बताता हूँ बिफोर स्टार्टिंग।
जब स्टार्ट करने वाला तो मुझे बता दो। एक्सक्यूज मी सर, sir, sorry for making you wait. There was a loose connection. We have fixed it now and we are ready to start again.
Go.
Sir, so the drone gets to a height of 3 meters after getting armed. रिपोर्ट किया था ना? Sir, the drone has reached waypoint 1. The battery is currently 13.5. क्या हुआ? हुआ क्या?
Okay, I think you tried your level best. I think you could take off and show it. Okay, good show. Okay, thank you.
नेट में लड़ गया था ऑलमोस्ट.
नहीं आएगा? नहीं
Can show me.
क्या? कुछ आया?
Anything has come?
इसमें कुछ नहीं है.
It's okay. It's okay.
It is being sorted. Also the appreciated as well. So one of our novelty of our Ascend is that the design is fully indigenous. So from the drone design to the base station.
Participate in Giant Hunt, India's largest anime contest. Create the world's first online register பண்ணா 3000 rupees gift prize தான் waiting. So இன்னும் எதுக்கு wait பண்றீங்க? Draw your answer.
A very good afternoon to everyone gathered here as well as who have joined online. As we reach the valedictory function of IRoC-U 2026, let us begin by paying tribute to our great nation. I request you all to rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you. Please be seated. What an amazing 3 days it has been. The vibrant enthusiasm and anticipation, the innovative streaks, some tense moments faced during the demos in the challenge, the perseverance to find solutions to overcome those challenges, the team spirit, and above all, the learning journey, which I am sure each of the teams have gathered during this time of trying to meet the objectives of IRoC-U 2026. Indeed, we could see itself getting manifested here, the 7 C's of innovation. And what are the 7 C's? The context, commitment, capability, collaboration, creativity, culture, and communication. After the demonstration by the 20 finalists, under the keen eyes of the esteemed evaluation panel, we have now reached the valedictory ceremony of ISRO Robotics Challenge URSC 2026. And on behalf of the organizing committee, I extend a very warm welcome to each one of you gathered here, as well as the viewers who have joined us online. We are indeed honored to have Dr. V. Narayanan, Secretary, Department of Space and Chairman, ISRO, who is gracing the occasion in person with us here today. I invite you, sir, to grace the dais here. And along with sir, I also invite our other dignitaries, Shri M. Shankaran, Director URSC, Dr. V. Koteshwar Rao, Chief Evaluator IRoC-U 2026, and I request Shri KVS Bhaskar, Chairman IRoC-U 2026 Organizing Committee, to escort the dignitaries to the dais and take your seats, please. As a gesture of welcome, we now present saplings to our dignitaries. I request Jyoti to present a sapling in welcome to Chairman URSC, Chairman ISRO. I now request Neha to present a sapling in welcome to Director URSC. We now welcome Dr. V. Koteshwar Rao, Chief Evaluator, and I request Ankit to please come and present the sapling. I now request Suresh to present a sapling to Chairman of the Organizing Committee, Shri KVS Bhaskar. Thank you to all our dignitaries for gracing the occasion and supporting this initiative so wholeheartedly. We are happy to have in our midst our controller URSC, Srimati Anjali Ali Shankar. And ma'am, we welcome you here with a sapling. I request a sapling to be presented to Srimati Anjali Shankar. I also extend a warm welcome to all the URSC Council members, senior colleagues, friends, online viewers, and our special guests, the young go-getters and participants of the IRoC-U Challenge. We are indeed fortunate to have as our chief evaluator for IRoC-U 2026 a person who is a storehouse of knowledge with a vision so sharp that there is no scope for any confusion. जैसा कहते हैं, दूध का दूध और पानी का पानी ही कर देते हैं. It is Dr. V. Koteshwar Rao, former Director LIOS and former Scientific Secretary ISRO, encouraging all the teams and at the same time drawing the line wherever required in a very encouraging and motivating way. He, along with the other members, the judges on the panel, had a very tough job on their hands, as you can be sure. I request you, sir, to share your insights and feedback, thoughts about this challenge, and also walk us through this evaluation experience. Dr. V. Koteshwar Rao.
Respected Chairman ISRO, Director URSC, Mr. Bhaskar, who is the chair of this IOC Organizing Committee, dear friends and my dear young friends, a very good afternoon to all of you. And Anuradha told, amazing 3 days. It was really amazing for us. It was like a festival, what we call a utsav, okay, nothing less than a utsav. So many young friends participating and celebrating the utsav was a feast for the eyes of all of us. I think the theme of this IRoC-U, the young minds, bold innovations, and the spirit of competition, lived through by spirit and deeds. I think I compliment all the youngsters who have participated with the spirit of competition in this challenge. For any organization, it is their responsibility to nurture the younger generation who can take care of the future of this country. The future is in your hands. And to that extent, I compliment ISRO and URSC for conducting this since 3 years. All of you are aware, after the success of Mangalyaan and Chandrayaan-3 landing, the response what ISRO got through social media is enormous, enormous. If I tell you statistics, when Mangalyaan was launched, hardly we had 3-4 months in that calendar year for the Twitter. And if you see at the end of the statistics of the full year, Mars orbiter mission stood at the 5th position. That type of response is what ISRO got. And later, inspired by this Chandrayaan-3 landing, I think Chairman ISRO and URSC Director have thought of a novel program of giving these challenges. I think in the series, this is the 3rd challenge, and I really compliment them for successfully completing this task. I really compliment Mr. Bhaskar and his team, a wonderful job, which has made our job, of the evaluator's job, very less painful and easy to walk through. And it is not an easy job. I was supported by the eminent experts like Jagannath Das, Dr. Ravi Kumar, Prashant, Dinakaran, and Sri Vidya. My job was very easy. I totally depended on their evaluation. And I think evaluation was very fair. And when I interacted with the students also, I got a feedback that they felt it is reasonably fair. Our motto was not to send any team or any person unhappy back home. The competition was very close. The competition was very, very close. And some of you must have narrowly missed. But nothing to worry. What is important is the spirit of participating in the competition. And this theme was to explore the planet Mangal. And we started on Mangalwar. And we started in Mangaladham. So it is not a rare coincidence, and it augurs victory for all of us. I see a lot of people with colored t-shirts. Yesterday I was asking them why this color was chosen. I was also not knowing. Later I came to know the Mars is of that color, the arena is of that color, and the organizing team have thought of those minute details and given these t-shirts to you, and you enjoy these t-shirts throughout your lifetime. Preserve it, okay? Then coming to the evaluation, we were given a tough task of completing within no time. I think last team has completed their demonstration just before the chairman has arrived. And I really compliment my panel members. With their support, we could complete within 2 minutes of the final demonstration, and the results are in the sealed cover, which I will hand over to the organization committee chairman, Mr. Bhaskar. So at this juncture, I would like to say only one thing. The future is bright for all of you, and India's future is bright. Thank you. Jai Hind.
Thank you, sir. As you said, success is not just about reaching the top, but about enjoying the climb. And that is what this challenge has been all about. Motivation is the catalyzing ingredient for every successful innovation. I'm sure all of you will agree. And propelling innovation, be it at our center, URSC Satellite Center, as is evident from his brainchild Spotlight at URSC, or propelling innovation among the young minds by initiating the IRoC-U in 2024, is our director, Sri M. Shankaran. Sir has always endeavored to think out of the box. He believes, as Nelson Mandela put it, it always seems impossible until it is done. I request you, sir, to share your thoughts with us.
Thank you, Anuradha. Good afternoon. So this year's celebration of youth and technology at URSC is coming to an end today. As was already told by Koteshwar Rao sir and Anuradha, we started this after the successful landing of the Chandrayaan 3. So the 24, IRoC-U 24 was the first one announced in the month of November 23. Now we are completed the 3rd edition of it, and I am very happy to tell you that we are ready with the 4th challenge, which we will be announcing shortly. This time we are thinking we will announce little earlier than November, December. Maybe we will request Chairman ISRO to announce it during the National Space Day during August 23rd, which will happen in one of the cities. So at that time we will request him to announce so that this becomes a non-stopping rolling chain. That is what we will do. So coming to this year's challenge, as I mentioned 2 days ago on the opening day, let me first congratulate all the 20 teams who could make to the final round, where your field round, you are come and demonstrated your hard work over the last 7-8 months. So congratulations to every one of the 20 teams. And congratulations also are due to the remaining 600 odd teams who had taken it upon themselves at least to enter into this, register for the competition and did some work on this. So congratulations to every one of you. Now, as sir was telling, winning is not the most important, but winning is also important, because nobody wants to end up on the not winning side, though participation is most important. That's how we have been all told right from childhood, and we have learnt. So participation is very important, but more important than participation and winning, in my opinion, is this experience of doing this for all of you over this last 6-7 months. This is the most important takeaway, in my opinion, from this competition. Because most of you are first year, second year, maybe a couple of you maybe from the third and final year of your courses. So most of you belonging to first and second year of your course, and you taking up a challenge like this, which I mentioned day before yesterday also, a challenge which even ISRO has not yet successfully completed. These challenges have been put in front of you, which has no previous art exists in this country. Maybe somebody else in US has done, or China has done, but we have not yet done. In India, nobody has done. So that you have taken up a challenge like that, and that you worked with so many people, went through iterations of the design, went through some heartbreaks, went through some euphoric moments, and finally come here and demonstrate as a team how good you are. This experience must have taught you something. What I'm thinking, at least I do not know, I have not experienced this, what you are experiencing today. I can only imagine what it would feel like if I were in your place and enjoying this and experiencing this. I can only think that it must give you enormous confidence, tremendous amount of confidence in yourself, in your abilities, and in your ability to work with others, work as a team, and explain to people, other people about your work. Doing work is one thing, and explaining the work clearly in an understandable manner to another person is another skill. So all of you have done all these things, that you have not only done an excellent work, you have also worked along with a large number of people, and you have also explained your work to many people. So many congratulations to every one of you for this outstanding effort. Whatever be the result, all of you are winners because of the very effort you have put in, and the experience which you have gone through is going to go a very long way in your future life, both academic as well as professional life. These are the kind of experiences that shapes a person's persona. So I am sure that you will carry a lot of takeaways from this experience of participating in IRoC-U 2026. And let me join all my colleagues here, and on behalf of the Chairman ISRO, wishing you all of you the very best in your both academic as well as professional careers, and keep rocking. Thank you.
Thank you, sir. Your words always instill a josh in the youngsters as well as all of us. And like is evident from what sir said, the most certain way to succeed is always to try just one more time. You all know the example of Thomas Alva Edison, right? So keep rocking and keep going. To commemorate the journey of IRoC-U 2026, and to capture the spirit, achievements, and moments from this challenge, a souvenir has been prepared, and we now invite our dignitaries on the dais to release the IRoC-U 2026 souvenir. I request Saira, a member of the organizing committee, to bring the souvenir for release, and I also request our controller URSC and alternate chair of this organizing committee, Srimati Anjali Madam and Dr. Shankara to please come on the dais and join for the souvenir release. Saira. Go. Thank you, dignitaries. It is said, innovation is the unrelenting drive to break the status quo and develop anew where few have dared to go. And leading and guiding the ISRO fraternity from the front has been always our Chairman ISRO and Secretary Department of Space, Dr. V. Narayanan. Instilling the scientific temper in the youth has always been close to his heart. And we are deeply honored to have you here, sir. And I request you to address the gathering. We are really looking forward to hearing from you.
Very good afternoon to all of you. Mr. Sankaran, Director, URSC, our beloved and very senior, Dr. Kodiswara sir, Mr. Bhaskar and the team members, URSC friends, and my dear young colleagues who have participated in this very important competition. I understand there are 20 teams, 200 members. My greetings to each and every one of you. Let me formally welcome all of you for this very important function. First of all, let me congratulate each and every one of you, team members who have participated in the final. You all are winners. Let us give a big hand to all the people who have participated in the final thing. Now, when you talk about a competition like this, even though it is our responsibility to decide the winners, first rank, second rank, third rank, and the consolation prize, I consider all of you are equally knowledgeable, equally important. Probably the people, those who are going to get the prize, they may be little, maybe 1%, 2% only different from others. This type of competition, it is rather than winning the prize, it is the sense of participation, understanding the system, that is what is very important. Now, you all know, 23rd August 2023 was a very historical day for the Indian space program and the entire country. And our Chandrayaan 3, first time successfully soft landed near South Pole of Moon, and India becoming the only country and first country soft landed near South Pole of Moon. And that day was announced as the Space Day celebration by Honorable Prime Minister of India. And I think now we are in that process of celebration. This is the third series. I think as part of that, this competition is organized. And while coming, I was wondering, this is a very good hall for, generally for reception, marriage reception and other things. I was thinking where I am entering. Am I entering near Mars or near Moon? That type of environment itself is made. And then coming here, you know, when we were students, we have heard about robots, only we know the spelling, we didn't know what it is. But then today, it has become a child play for each and every one of you to make a robot and then participate in this type of competition and understand the entire system. Now, dear friends, when you look at our country, 1947, when we got independence, I think the stature of country was very average. I think, I don't know how many of you are aware. Almost 97.5% people are below the poverty line. And education, if you take education as a sector, only 12% people are having the literacy level. And today from the 12% we have come a long way, almost 80% people are literate. And when we got independent, there were not much standard institutes in the country. Even engineering colleges were very, very limited. And there was no IITs. Even first IIT was started only 75 years back, 1951, August 18. IIT Kharagpur, I am so privileged to be the alumni of that IIT. And then All India Institute of Medical Sciences, IIM, everything has come much later. And when we were studying in the college or school or college, there were not much opportunities. And the science and technology growth in the country was really, we were much below average. And from that level, you take any sector, take agriculture sector, from net importer of food grains, today we are exporting food grains. Almost the food production has gone almost 6 times from that time to now, and we are exporting. And then you take infrastructure development. You know, there was a time, if somebody has to travel from here to Delhi, it is a big job by itself, by train or any other means. But today, the infrastructure development has gone to great levels. And academic institutes, I think lot of standard institutions, 27 IITs if I am correct, 27 or 28, 27 IITs and IIMs, lot of growth has happened. Now coming to the space sector, when we got independence in the country, rather globally, there was space, but our country, there was no space program. All started by the visionary leadership, the visionary leader, Sarabhai, 1962 only it started. And in the initial phase, you know, we have come gradually, we have moved forward. 1963, November 21st, a tiny rocket lifted off from Indian soil, marking the first major achievement. And that rocket, you know, who gave? The rocket was given by none other than USA. And the payload for that rocket came from France. And everything was assembled in Indian soil with other support, and it was launched. And from that humble beginning, getting a tiny rocket from America, last year, an important achievement, 2 important achievements happened last year. One of the important achievement was using our Mark 3 rocket, we lifted off a satellite, got Bluebird 2 satellite, purely on commercial basis. A 6,000 kg satellite built by American company, commercial basis we lifted off from our soil. So that was a major achievement from 63 to now, getting a small tiny rocket, and today we are launching their rocket. And in NISR, I don't know how many of you are aware, NASA ISRO synthetic aperture radar satellite mission. And you know, there was one payload built by America, including one unfurlable antenna, and another payload we made, SAR payload we made in India, S-band SAR payload made in India. And the entire satellite was built only in URSC here in Bangalore. And it was lifted off by a rocket called GSLV Mark II rocket, for which the upper stage, cryogenic stage, the technology was denied by spacefaring nations. The developed countries were denying the technology. In fact, when we were launching the previous day, there was an article written by one of the NASA scientists, retired scientist. He has written, a rocket which we tried to kill at that point of time when they were developing. Today we are using same rocket for launching the NISR satellite. So that is the type of growth which has happened. And huge development has taken place. Now you take Mars orbiter mission. Now please understand, going to red planet is not that easy. And almost if you take the path, elliptical path, the path in which we have traveled, 68 crore kilometers we have to travel. And going 68 crore kilometers, I think you all are engineering or you all are students, you know trigonometry. Please do a simple calculation if you travel with 0.01 degree error. 0.01 degree error. If you travel, when you travel 68 crore kilometers, where you will reach? One will not reach Mars, you know. Some other place we will go and we cannot capture. And we have gone there, and after almost 295 days, the Mars orbiter was captured in the orbit, and India is the only country till today succeeded in the Mars orbiter mission in the first attempt. And none of the other developed countries could achieve in the first attempt. And of course, we are very good in learning from others' failures also, and we have done that. And of course, a lot of international support was there, but even with support, but we have achieved that mission in the first attempt itself. Now you take Chandrayaan. Chandrayaan, 1969 itself people have landed on moon. But even though those things happened, it was our Chandrayaan 1 which found water molecule on the moon for the first time. And America and Russia, India can be the two proud countries for that great achievement. And Chandrayaan 2, I think I don't know how many of you are aware, we gave even though we could not soft landed, in my assessment, of course there can be difference of opinion, the achievement was 98%, it was a successful mission. You know why? Today we are having an orbiter going around the moon. You know who is having the best camera in the moon orbit today? You don't know. It is Indians who are having the best camera in the moon orbit called on-orbit high-resolution camera. And some 2 months back, a Japan team, they were presenting in one of the hotel here. They were showing the photo taken by the Mars, the moon photo taken by our orbiter, our camera, and one of the developed country camera side by side. And by seeing, everybody can conclude what type of quality we are having. Today I am proud to say that our photos are the best photos available with respect to moon's photos. So that is the type of growth what has taken place. And lot of activities are happening. Probably this is not the time to explain everything. And coming to application, today I cannot imagine a country without satellite application. Probably we used to tell in a very jovial way for the common people to understand the importance of space application. One day evening between 5 o'clock to night 10 o'clock, we should switch off all the satellites. If you switch off the satellite, I think lot of activities will come to a standstill. You know, there was a time when you go from one city to another city, we carry a lot of money. But nowadays everybody has got only some cards or some mobile. Nobody carries money. And no transaction will take place if the satellites are switched off. And when we joined ISRO, almost 42 years back, when I joined ISRO, if you have to make a phone call from one part of the country to other part of the country, we take almost 2 hours to make one phone call. Because you have to go to telephone booth, wait, and trunk connection. Then you know the signals will be so bad. Once you get connected, most of the time it will get disconnected. And nobody will allow us to dial immediately, then you have to come back in the queue again. And standing lot of time. But today, can you raise the hand who are all not having mobile in the hand? Can you raise? My God, everybody is having. And that is the type of development which has taken place. So telecommunication, lot of contribution has come from space. And another thing, you know, television broadcasting. After I completed my MTech in 1988-89, completed my MTech. During that time, there was a program called in Chitrakar. Only 5 songs per week you have the right or eligibility to see in the TV. If you miss that songs, you have to wait for 1 more week. But today that is not the situation. Whenever you travel, immediately you can go to YouTube or lot of channels are there, you can see. So like that, lot of achievements, accomplishments, and 10 scientific missions we have accomplished, and lot of good things have happened. Now the purpose of this meet is to make scientific temper among the youngsters. You know, today, a country which was importing food grains, and 97.5% people were below the poverty line. Now, you know what is meant by poverty line? I will just explain what is the meaning of that poverty line. I am from a village in Kanyakumari district of Tamil Nadu. In my village, out of 150 houses, hardly 25% family only had the privilege to take food more than 2 times per day. 2 times or more than 2 times. Otherwise, 75% people used to take only 1 time food. This was the situation when you talk about that poverty. From that stature, today, economically, we have bypassed UK, who were ruling us for years, and we have reached 4th status, even bypassing them. And we are aiming for reaching the 3rd position. And Honorable Prime Minister is working for making this country as a developed country. And I am 100% confident the country will become a developed country before we celebrate 100 years of independence. I am 100% confident. Because we can understand, you know, we can extrapolate Economically, where we were, today where we have reached. Infrastructure, where we were, where we have reached. And education sector, where we were, today where we are. And every area we are growing. But lot of things have to further happen, but surely the country will become a developed country. And with respect to space, lot of new things are there. We are going to build our own space station. We are going to have our own Gaganyaan program, sending our Gaganyaan 3 to space. And by 2040, we are going to land on moon. That is what is the program. Honorable Prime Minister has given one direction to work on that. And lot of good things are happening. Now, you all youngsters are, I will say, so privileged, lucky generation. Because the current generation, the time is such a way that you have got great opportunities to improve your capabilities, caliber, not only improving the capability and caliber, also to contribute for the growth of the country. Now today, can you imagine 40 years back we were not knowing what is a robotic arm or what is a robot, what it can do, what are the benefits we are not knowing. Today it is like a child play you all are handling. So the purpose of this competition is to make you aware of not only robot but also bringing you here to understand little bit about the scientific growth of the country and also the growth of the space sector in the country and the contribution of the space sector in the country. Also to enable you to do some sort of teamwork together. You know, when a student is studying, okay, individually you are studying, you are getting good mark. When you come out from the student life, the success is depending upon teamwork. If you cannot work in a team, you cannot contribute. Somebody is thinking that he is outstanding, he is excellent, not in a position to work in a team, surely your contribution will not be that significant. In fact, ISRO, today it is a successful organization. It is only because of the teamwork. Only because of teamwork, it is no individual is responsible. Even though individuals have got great knowledge and idea, it is the teamwork which matters. So when you come here, important thing is only you had the opportunity to connect with your own counterparts from other part of the country. Please have good friendship, good relation. This will really help in a long way. Whether you get the award, reward, that doesn't matter. All of you are winners only. And I have to thank Mr. Bhaskar and the team for doing great job. Almost 6-7 months they have put the effort. And till I came inside, I didn't know that Kodiswara sir is involved. He is one of the best space scientists what the country has generated and what he is here. And really you all are so lucky and privileged to have him with you. You know, in ISRO, I used to tell, in fact, I used to tell my children and my wife, when you join in a government job, everybody will get salary. But ISRO is a unique organization. We come in contact without paying anything with great people like Kodiswara sir. There are a lot of people like him. He is one among them. So it is a great honor and privilege for all of you to come in contact even with that great person. Now, last year, you know, when we started our space program, even we were not having proper transportation system to move our rocket parts. We were moving our rocket parts in old bicycle. Because this bicycle I cannot forget because 1982, I joined, my first appointment was in a cycle manufacturing company called TA Cycles in Chennai. From that, moved to rocket place. So I cannot forget, those days they have moved rocket parts with old bicycle. And here, the Apple satellite for an experiment, it was moved in Bangalore road with the bullock cart. From that area, we have come a long way. Last year, we did a couple of important achievements. One of the achievements is docking experiment. I don't know how many of you know what is the docking experiment, what we did. You know, docking experiment, let me explain in a layman language. Assume 2 cars are going in Bangalore road. And if you are to, without stopping, and you have to connect mechanically, you can understand, you know, what type of difficulty it is. And 2 satellites rotating with 28,000 km/h speed with a relative velocity is very less. And in space, without any support of human being, automatically using set of cameras, propulsion system, navigation system, we have to connect. It is not that easy job. If it is that easy job, every country in the world would have done. And we are the 4th country succeeded last year, January 16. You know who is It is a teamwork. ISRO work is a teamwork. We cannot give credit to only one person. But in ISRO program, I want to tell, even though it is a teamwork, the success or failure is finally in the hand of few people. And one of the greatest leaders is Mr. Shankaran, who was responsible for accomplishing that docking experiment. And when I say the Shankaran responsible for that docking experiment, he was in the forefront, leading the team, guiding, and finally we achieved, and we are one among 4 countries accomplishing that. And if I have to talk about his accomplishment, it will take another 40 minutes. I am not going to venture into that. So you have the opportunity to come in contact with such a great personality. Maybe very simple way, he's sitting there, but then very difficult to come in contact with such a great personality. You had that great personality. And now we have got great other people, like Bhaskar and other people. Each and every people who are here from URSC, probably they may be talking with you with polite language, they are mixing with you, but everybody is with 30, 35 years of experience. Great people. Every individual in ISRO is great. In fact, the other day, on 18th of this month, we had a great occasion. One of the Indian startup company had the first time the sky route. They succeeded. Of course, with the total support of ISRO team, including former retired people, 30 people were involved in the game, then we have supported, and finally they succeeded in accomplishing a first time orbiter mission. So the reporter, NDTV reporter asked me a question. So they have sent the diamond to the space. So what is your comment on that? You know, what was my comment? I told one diamond we have sent, but in the campus there are thousands of diamonds are there. Thousands of diamonds. Each employee, each scientist, I consider equivalent to a diamond only. Because, say, when you talk to them or when you this one, they also don't know they are much more than diamond, their knowledge. But that type of contribution people have made, and you are so privileged and lucky to come in contact with such a senior people. And dear friends, I would like to tell a couple of things. It is good that you have participated. Now, please learn well and enable well and have good connectivity, and at the end of the day, you have to contribute for making our country as a developed country before we celebrate 100 years of independence. Surely the country will become a developed country, but you should be a part of that in one way or other contributing. And also, please have the attitude to work in a team. And individuals are important, but teamwork is very, very important. And have a balanced between personal and professional life. We are all, including my Changaran and Kodiswara and our generation, little we have lagged in that. We have given more time to professional life and than personal life. But then, yes, 40 years back, that was the situation. A country which is not in a position to feed our own citizen, and just space program is starting, and bicycle we are moving the things. And then some people have to sacrifice, so we were not having balance. So I suggest you should have got a balanced professional and personal life. And all the best for each and every one of you. On behalf of the space community of India, our greetings to each and every one of you for your successful professional and personal life. All the best. Thank you. Jai Hind.
Thank you so much, sir, for your ever-inspiring, motivating, and guiding words. And as you have said, I'm sure if we have to reach the top and become a superpower and become the developed nation, we have to learn from our heritage, we have to be proud of our heritage, and at the same time, keep our eyes and focus fixed on the goal, on our dream. And that is going to become a reality when each Indian takes it up as a motto, especially the youth of the country. So it is in your hands. Each one inspire another 10, and that is how we will move forward and achieve the goal within the dream of the nation by 2047. We take that message, sir, and I hope that everyone will work towards it. As has been said, patience and perseverance have a magical effect, before which difficulties disappear and obstacles vanish. So these are the key things which will take us forward. And thank you, sir, for your inspiring words once again. Now, before we go to the word of thanks, I would just like to say that after the word of thanks, we will have a feedback from one or two students. So please keep yourself prepared. We will request your feedback to come on the dais and say a few words. So now I request to propose the formal word of thanks. I invite the alternate chair of the organizing committee, Shri A. Shankara, to come on the dais.
Good afternoon, sir. Good afternoon to all of you. As we come to the conclusion of IRoC-U 2026 activities, which commenced on 21st July, it's my privilege to propose word of thanks today. Over the past 2 days, we have witnessed outstanding demonstrations of the Ascend activities by 20 talented teams. The enthusiasm, innovation, and technical excellence displayed by the participants have truly made this event very memorable. Despite his extremely busy schedule, Secretary Department of Space and Chairman ISRO, Dr. V. Narayanan sir, graciously accepted our invitation to participate in IRoC-U 2026 valedictory function. His primary intention is to interact with the students and inspire them to pursue excellence in the field of space technology. On behalf of the entire IRoC-U organizing committee, I express our sincere gratitude to Dr. Narayanan sir for his gracious presence, unwavering support, and invaluable guidance. The journey of IRoC-U 2026 began somewhere in January 2026. Almost 6-7 months back, we started this activity. Throughout the planning and execution of this event, our director, Shri M. Shankaran sir, extended his constant support, encouragement, and invaluable guidance. His enduring support has been instrumental in the successful conduct of this program. On behalf of the entire IRoC-U organizing committee, I convey our heartfelt gratitude to sir. I extend my sincere gratitude to our controller, Madam, Srimati Anjali Madam, for her excellent administrative and logistical support, which was instrumental in the successful conduct of this event. My heartfelt thanks also goes to the URSC Council members and the group directors of all areas for their continuous support from the very beginning. I would like to make a special mention of Shri Sunil Kulkarni and Shri Jyoti Soman, the earlier organizing committee executives, that is IRoC-U 2025 executives, for their valuable experience, timely guidance, and practical suggestions at critical stages made our work very easy. I express my sincere thanks and appreciation to the panel of judges led by Dr. Koteshwara sir, former Scientific Secretary ISRO, along with Shri Jagannath Das, Srimati Shri Vidya, Shri Ravi Kumar, Shri Dinakaran, and Shri Prashant, for their meticulous evaluation and valuable assessment of the participating team. I also thank all the engineers who visited various institutions across the country to conduct the field test evaluations. Their dedicated efforts ensured a fair and comprehensive selection process. A very special word of appreciation go to Shri Bhima Rajappa, Group Director C&MG, and his entire team for creating this wonderful arena. That's what we are seeing. Today, Mangaldam truly resembles a 35 feet by 25 feet area, miniature Martian landscape. This remarkable achievement is the result of several days of untiring effort by C&MG staff. I also thank the carpentry team for their craftsmanship in developing the 7 terrain features, which are beautifully camouflaged within the Martian red soil. That's what you can see. My sincere thanks are due to the drafting facility for their outstanding support in designing the invitation card, banners, backdrops, trophies, and other event materials. I also thank the audiovisual team and CIG team for their excellent effort in live streaming this event on YouTube, enabling a wider audience to witness these inspiring activities. I sincerely acknowledge the wholehearted support extended by our administration, purchase, accounts, PRO office, transport section, canteen, and Mangal Dham staff. Their seamless coordination and dedicated service contributed significantly to the smooth conduct of this program. I would be failing in my duty if I do not express my sincere gratitude to the students, faculty members, and educational institutions who participated in IRoC-U 2026. More than 590 institutions initially registered for their interest. Over 250 plus institutions submitted their field test videos, and our evaluation team visited more than 35 institutions before selecting 20 finalist teams. Those teams have demonstrated their innovative solutions here. I congratulate and thank each and every participating institutions, every student, and every mentor. This event would not have been possible without their commitment and hard work. I also thank all the URSC employees who visited the venue and encouraged the participants throughout the event. Your presence and appreciation meant a great deal to the young innovators. Finally, I express my gratitude to every member of this organizing committee, every volunteer, and every individual who worked behind the scenes to make this IRoC-U 2026 a very grand success. Once again, I thank each and everyone for your invaluable support and participation. Thank you all.
Thank you, Sri Shankara. Now we would like to have a few of our college participants to give feedback on your experience and your thoughts about IRoC-U and what you felt during this journey. Yes, please. Nice to get a prompt response. Please introduce yourself with your name and the name of your college.
So good afternoon, everyone. Greetings to the respected Chairman, Sir of ISRO, and every eminent dignitaries present on the dais. My name is Anushka Pankaj Gupta, and I'm a student of third year CSE AIML from Yashwantrao Chauhan College of Engineering, Nagpur. My team, Team Titans. Now, what exactly does Titans means? Warriors. But we are here for an ISRO Robotics Challenge competition. Then why warriors? Because in this competition, I've realized that every scientist is a warrior. Challenging conditions, sometimes things don't work as you want. There are some happy moments, there are some sad moments, but a warrior is stood firm and fighting against everything recklessly, being calm and composed. This competition began on December when the problem statement arrived. My team, full of freshers. Most of us learned to download VS Code for the first time when we came. But today, I'm so happy with their performance. This transition of 8 months, the video round, the elimination round, when we first came to know that we will be, us ISRO scientists will be visiting our college, we had immense joy. And when we met him, we saw an ocean of knowledge. We successfully qualified that round as well. Then we came here, competing against the top teams of the country. And in this journey, I saw that we developed patience, endurance, and knowledge. All these things made us realize that being a warrior and being a scientist is no less than, no more difference is there in that thing. I'm so grateful to the organizing committee for creating challenges so intellectually and architecturally intelligent way. When I saw the features, that was the moment I realized that coming to the top 20 teams was a thing, it was a challenge. But getting into the top 3, detecting those features, yes, that was a challenge. And that's what gave us the edge. The problem statements, the arrangements and everything was wonderful. And I would like to really, I want the audience to clap for the organizing committee of IRoC-U 26. people who are contributing to the country as well as making junior scientists, preparing us for the future is what URSC ISRO is doing through this competition. Thank you so much, guys, for this. And a small request I want to make to the organizing committee that since last year, you invited only the mentors and the students for the Bharat Mandapam. I want you to please invite the entire team because I am nothing without my team. And whatever it might be, a victory or a learning, but it is all of the team. So a small request I want to make to you. Okay? Thank you so much.
Thank you, Anushka. I think you summarized the feeling for everyone from the start to the culmination. Thank you for your words and appreciation. Any other member? Yes, please.
Meanwhile, I would like to say one observation. The most of the teams, the boy students' participation is more and the girl students' participation is less. Whenever I go to engineering college and peep into the classroom, half of the section is almost girls. But the same spirit I want to see in this type of competition also. I request the next organizing committee to announce a special prize for all girls team, if possible.
Very good afternoon to all the respected dignitaries present here. So the challenge started right away from the ideation round, in which I think every team would have been sitting in a round, brainstorming their minds and finding what solutions we could find for this enormous and great challenge which the ISRO had proposed. All the ideas which all the teams had proposed are very good, and I am sure that all the teams would have given their best efforts, sleepless nights, and there have certainly been ups and downs for every team. But going prior to this and solving all these challenges has been a great to all the teams. And I would like to thank ISRO, URSC, and IRoC-U to present us with this competition and make our ideas a practical innovation and present to you and give us the platform to present our ideas. Thank you. I'm Manav Patel, currently in third year CSE from Nirma University, Team IRO. Thank you.
Thank you, Manav. Anyone else? Do we have anyone else to provide their feedback? Okay, please come.
Good afternoon, everyone. This is not my first time coming for the ISRO competition. On my first year, I registered for the ISRO competition, but we couldn't come for the finals. But this year, we made it into the finals. So when we see the calendar of the ISRO competition, it aligns perfectly for us. Whenever the waiting time for the results, we have our exams. Whenever it is the time to prepare for the competition, we have the holidays. So the calendar is perfectly fit for our college. So it gave an upper hand for us. And then regarding the feedback, the arena is perfectly fine in the indoors. But one thing I request you, sir, to upgrade is this year the competition is based on mostly VIO, like visual inertial odometry. The external field for testing was little dangerous for us to test because the futures were not sufficient, or the lighting conditions made our VI to recognize the futures. So it will be better for us as well as the other teams to test their drone the previous day. So that we request the outer arena to be covered from the sunlight, sir. That's it. Thank you. Myself, Dhanush. I am from Amartha Vishwavidyapeetham, Chennai campus. Our team name is Team Quantum Run.
Okay, thank you, Dhanush. And congratulations to your team for making it to the finals. Perseverance truly pays. So we may have time for one more feedback if someone wants to come. Yes, please.
Okay, hey everyone, I'm Anant. I'm from Sihagan Institute of Technology, Lonavala. My team name ISRO. So starting with the experience of my team, I still remember when it was the elimination round or qualification round, I don't remember. We were having our end semester examination just 2 days after that. My senior's exam was there on the same day when we were having our submission. And we were like, we don't want to give this submission and all, we don't want to give this end semester and all, we just want to focus on that. Well, first of all, I would like to thank the whole organizing committee for giving us all the students a chance for just presenting our ideas and just to get an opportunity for us ki like वापस एक बार कुछ तो ऐसा दिखाना है हमें कि लाइक हमने भी कुछ सीखा है, हम भी कुछ सीख रहे हैं एंड हमें और भी कुछ लोगों को बताने की एक ऐसी चीज़ है तो हम एक और भी स्टेप आगे बढ़ के एक नया कुछ तो क्रिएट कर सकते हैं. एंड टॉकिंग अबाउट माई टीम गेव देयर 100%. वेल वी एवर समथिंग कि सोच रहे थे कि लाइक वी डोंट वांट टू यूज़ सम सॉर्ट ऑफ लाइक जो पहले से बन चुका है. वी वर थिंकिंग कुछ तो नया चीज़ करना है. फॉर दैट व्हाट वी डिड कि लाइक वी स्टार्टेड फ्रॉम मेकिंग ऑल द थिंग्स कस्टम. वी डायरेक्टली थिंकिंग टू मेड अ न्यू whole frame of the drone where we started from one thing like matching one parameter and like creating new ideas for us. Well, regarding the feedback, the arena was so great for us. Like when the first look which I gave to it on the inauguration day, I was like, yes, now we are going to win. Although with some errors, with some glitches, we were not able to take a proper flight. But I would congratulate the whole teams for making it to finals. And yeah, thank you.
Thank you, Anand. I really liked your especially the last part, where you realize that it's the learning and the efforts which we put in and your teamwork, which is what is more important. It will take you much ahead. Congratulations, and it's very heartening to see feedback also coming from teams from all across the country. This 590 registrations, sir, which were there, has covered almost most of the country, so that outreach has really been great this time. We have time for any one last feedback if someone wants. Yes, please.
Good evening, respected judges and everyone present here and my fellow friends. I'm part of Team Wingman from Alliance University, Bangalore. My name is Aditya Sampath Kumar. So if I'm telling you guys about the challenge, it's almost being about 7 to 8 months of a long journey. When we first registered for the competition, our team, which consists of 4 first-year students and 1 final-year student, we knew it would be difficult, but we don't know. We just went for it anyway. And I'm so glad that we have made it so far. There were some nights which we thought, okay, it's not just possible. There were some moments when the drones crashed, and we kind of lost the hopes. But even though everything, we just went along with it. Step by step, day by day, we gained new experience, learned new things, changed our methods. And by all the things we have done, we have finally reached this final round, and we are really grateful for that. Thanks especially to our university and our mentor and everyone who has supported, including the ISRO people and everyone that's present here. We are really glad to have come so far, and thanks a lot, guys.
Thank you, Aditya. I think there's someone from that India. You've been wanting to come, so please, one more we'll take.
Good evening and thank you so much for giving me this opportunity to speak here. I am Isha Suryavanshi from Team Galactic Gearets, Pune Institute of Computer Technology. I wanted to talk about this competition because I think this has left a really huge mark on all of us. We started off in the month of December. After our team was formed, we went through a vigorous process of discussing ideas, testing, seeing what works, seeing what does not work, making a documentation, remaking a documentation, and discarding all of it and making it again. I think one thing that I really liked about this competition is that in our first years, we had a lot of things on paper. We did not know how things worked when hardware interacts with software. Via this drone and the base station system, we got a closer look that what works on paper might not always work on the actual arena. You have hardware constraints, things are slow, sometimes you never work out, sometimes things don't work out. You have to fix your methods, you have to optimize things. We had to do a lot of research which gave us an insight into how things actually really work. We know that it might not be like close to what scientists actually do, but I think this was an amazing opportunity. We realized that not like as engineering students, getting placed is one thing, but getting this opportunity to know things on a deeper level, to understand the mathematics, the electronics, the computer science fundamentals, the robotics fundamentals, and everything else that we learned in this journey was so amazing. So I would really love to thank the organizers. This is indeed a privilege and honor. I want to thank my college as well, my seniors, my teachers for this opportunity. And the amenities here have been amazing. The arena is kind of unexpected for us, but still very well made. The food, the compartments that we are in, really beautiful. We were able to stay for a lot of time at night as well to work our code out. One thing that someone also pointed out was the practice arena thing, that it was outside and we had some constraints working with it. But other than that, thank you so much to each and every one of the organizers. Thank you so much to all the scientists. It has been a privilege to meet you all. Like the first time we had the scientist meet, I remember that I went home and I cried to my mom that I don't know where this will lead us, but it has been an honor to know that my country is getting ahead, and because of some people, and I met one of him. So thank you so much for this.
Thank you, Nisha, for those impactful words. I think she has also summarized the feelings of people here. It's been nice receiving this feedback. I think they have taken us through the range of emotions which should be going on in the minds of all the participants. As we are drawing to the close of our valedictory function, we wish all the participants, the finalists, the very best. The results, as Sir has already said, would be announced on National Space Day. So may the best teams win, and advance congratulations. For the others, please keep your eyes set on the trophy and keep persevering. Just as we always know, creativity is seeing what everyone sees, but thinking what no one else does. So that is how we create new things from other seemingly mundane objects or thoughts around us. So let that creativity, that scientific temper and the spark be alive in you, and let it ignite the spark in many others. We draw the curtains on the IRoC-U 2026 challenge here for now, but let the spirit continue and lead us forward. Thanks once again to all the dignitaries, to the organizers, to all the participants, everyone who has contributed to this event directly or indirectly, and above all, to all the participating teams and colleges. Jai Hind. Okay, there's an announcement. High tea has been arranged. So I request the dignitaries who are sitting in the first two rows to please remain here, and the others can go down to the ground floor. They have to come here? They will come here? How should they? Just hold on. There is one surprise in store for you. How should we call them? Team by team? One team by one team at a time? Okay. So you have the opportunity of having a photograph or a selfie with our Chairman ISRO and all the other dignitaries on the dais. We invite teams to come one by one. They can come here? Yeah. So team by team can come. We will call you, maybe we'll start from here. Who is the first team here? Yes. Which is this team?
Wingman.
Huh?
10928. Wingman.
Wingman. Okay. So, okay, the second team has come. After this, I'll call the teams out aloud and they can come.
All of your arrow.
Some of you can sit there. Come. Team Dhruva. Team Dhruva. This team can come from here. After Team Dhruva, we'll have team from Lonavala, IIC, SIT. See, all the teams can come up from that side and come down from the left. So the next team is Team IIC, SIT. The next team IIC SIT, followed by the team Quantum Realm. The team, come first. The team after IIC is Quantum Realm. Please be ready on the right-hand side of the stage. Quantum Realm on the dais. And next team is Team Aviators. You are finished? Team Aviators. Are you here? Aviators is not there? Team Icarus. Yeah, please be ready. Team Icarus. The teams can come in from that side and they can come down from the left side, from my left side. Some of you can sit down. So Team Aviators is not there. Next is Team Icarus. And Team Orbit Dynamics, please be ready. Team Orbit Dynamics. Icarus, right? So after Team Icarus, Team Orbit Dynamics. After Team Orbit Dynamics, we'll have Team Luma. Team Orbit Dynamics onto the stage. Team Luma, please be ready. Okay, sorry. Team Qubit Dynamics. This is Team Qubit Dynamics, followed by Team Luma. Team Eternal, please be ready. Team Eternal. Team Luma on stage, Team Eternal to be ready. Team Eternal to come to the dais. Team Orbital Bytes to be ready. Team Orbital Bytes. After Team Orbital Bytes, Team Parallax to be ready. Team Orbital Bytes coming onto the dais. Team Parallax, please be ready. Orbital Bytes on the dais. So Team Parallax, please come on the dais. The next team will be RIG NITC. Please be ready. Team RIG NITC, please be ready. After Team RIG, Team Matrix, please be ready. Team Matrix. Is there anyone from Team Matrix? Team Wingmen. Matrix has finished? Wingmen has finished? Okay. So Team RIG on the dais. Team Matrix is not there. Team Wingmen has finished. Team Galactic Gearheads, please be ready. Team Galactic Gearheads. Team Galactic, are you here? Yeah, please be ready. Team Galactic Gearheads, please come on the dais. Team MANIT, please be ready. Team MANIT. The Team Galactic Gearheads on the dais. Okay, Team MANIT, please come to the dais. Team Golden Ratios, please be ready. Team Golden Ratios. All the best. After Team Golden Ratios, Team Aerial Robotics to be ready. Team Aerial Robotics. Not there? Team Aerial Robotics IITK. Okay, Team Titans. Team Titans, please be ready. So Team Titans, please come on the dais. Team Anvesha. Team Anvesha. It's not there. Team Arrow is over. So, okay. Team Anvesha, confirming no one is there. So the last team, Team Titans. Yeah, it's very heartening to see all the different types of drones which are kept here. That also shows the wide variety and creativity which people have used. So this was the last team. Yeah, that's it. Committee members? Yeah, okay. So the committee members are requested to come on the dais for a group photo. The committee members. There's high tea arranged. All the participants can go enjoy the high tea in the ground floor, and the dignitaries can please remain here. The committee members, please come first for a group photo.
Should I sit down? My height is less.
मेरी तरफ से आपको उसी का बुक उसी को दे दो बंद करना